In the vast expanse between Mars and Jupiter, a strange entity is adjusting its trajectory, and its destination seems to be aimed straight at us. The object 3I Atlas, once considered a harmless ice chunk drifting from another star system, is now gradually accelerating in a steady manner along an almost impossible orbit. Analyses from multiple independent sources based on Avi Loeb's data on non-gravitational acceleration near the closest point to the Sun show that if the thrust is maintained for just 50 days, its speed could change by up to 86 meters per second. That figure is enough to put it in a position coinciding with Earth on the 19th of December 2025. Is this just ordinary physics from dust and solar radiation, or a meticulously planned maneuver? And alongside that motion, a frequency of 1.4 GHz is ringing out with weak but rhythmic pulses, almost mathematical in nature, spreading through the void like an intentional response. The connection between the orbit and the signal has many wondering about coincidence. Some leading researchers are monitoring closely because these developments could upend our understanding of space. 3I Atlas is not simply passing by like previous objects, but seems to be aiming for a specific destination. If this story intrigues you as much as it does me, please like, follow to catch every latest update as the event unfolds live. Share your thoughts on the recent changes from your viewing location and local time. Spreading the information will help the community together unravel the cosmic mysteries. Thank you for everyone's support. You are the motivation for us to dig deep into phenomena like this. Opening part: shocking discovery. An entity from outside the solar system is entering our territory right now. This is a confirmed event, not far-fetched imagination. The object named Atlas first appeared on the 1st of July 2025 via the collision monitoring system in Chile. The special point is not just its origin from a distant star system, but also its current behavior, full of surprises. Many posts on X have spread a startling calculation. If Atlas maintains non-gravitational acceleration at 0.02 millimeters per second squared for 50 days, the velocity change will reach 86 meters per second. The result could lead to a position parallel with Earth on the 19th of December. Sources push further, suggesting this is not randomness but calculated action. They mention the 1.4 GHz signal potential trajectory adjustments, even linking to an object near Mars. Before dismissing as conspiracy theory, consider the basic facts. Atlas really exists with a hyperbolic orbit not bound by the Sun, coming from the deep void. Perihelion falls on the 30th of October, and there are reports of strange acceleration. Non-gravitational acceleration means a force beyond gravity is acting, commonly seen in comets when gas evaporates, creating small but cumulative thrust. The level of 0.02 millimeters per second squared is tiny, only a small fraction of Earth's gravity. But in the vacuum of space, it accumulates over days and months into major changes. Atlas is the third confirmed interstellar object. Before it were Oumuamua in 2017 with its strange shape, and Borisov in 2019 resembling a familiar comet. Atlas stands out with behavior that raises big questions. If just an anomalous comet, it still holds enormous scientific value, a piece from another star system revealing clues about planet formation in distant places. But if the acceleration is controlled, we face the prospect of technology from an alien civilization. The purpose of the analysis is simple: check. The claims examine the data, assumptions, calculations, distinguish fact from speculation. We will follow until the end of 2025 and early 2026, when observations can prove or disprove. Not to spark fear, but to grasp what is plausible. The universe is full of mysteries beyond understanding, occasionally challenging current models. Atlas could be one of them, or an ordinary comet but outgassing in a strange way. You will have the foundation to judge for yourself, grasping the science-math observations and broader implications. Structure divided into 3 parts, from claim data to speculative debate, then connecting to modern scientific progress. Before diving deep, the universe doesn't care about our comfort, doesn't care if we're prepared for revelations or not. Human history is full of abandoning central beliefs from Earth, as the universe is centered to the Sun being just one of billions of stars. Now we know objects from other systems can visit. If one such visitor acts in ways hard to explain, what follows next is real data for you to evaluate whether the claims hold or are just illusions. Core Data Part. Atlas discovered on the 1st of July 2025 via the Chile Telescope Network, specializing in detecting near-Earth objects. Initially just a moving bright spot, but the orbit revealed something extraordinary. Hyperbolic orbit proves not held by the sun high speed exceeding escape velocity coming from interstellar space, and will leave. This is the third interstellar object. Perihelion on the 30th of October, distance from the Sun 1.36 to 1.4 astronomical units, 203 to 210 million kilometers near Mars's orbit. Closest to Earth on the 19th of December, distance 1.8 astronomical units, 268 million kilometers. For comparison, the Moon is 384,000 kilometers away. Atlas is 700 times farther. Avi Loeb from Harvard reported orbital deviation from lab and Atacama data shift of 4 arcseconds significant at great distances. Acceleration calculated at 0.02 millimeters per second squared. If due to outgassing would require massive mass loss, 1/16th in a month, creating a distinct dust gas cloud. Non-gravitational acceleration common in comets when ice sublimates pushing the object. The issue with Atlas is the scale. If billions of tons heavy, that loss must create a large bright tail. Images show jet structures pointing toward the sun, green color suggesting ionized carbon monoxide. Interesting signs but not decisive. Loeb does not claim aiming at Earth or intent, just notes the acceleration deviation. Parallel claims come from social calculations based on data. The data is compelling, fits outgassing physics, unusual but feasible. The question is whether the data supports intent to aim at Earth or adds assumptions for sensationalism. Atlas really has a close but distant orbit. Acceleration could be natural. Calculation of 50-day thrust creates major change. Enough to align. Next part examines the math assumptions. Detailed math part. Calculation from basic formula: acceleration times time equals velocity change, with 0.02 millimeters per second squared over 4,320,000 seconds result 86.4 meters per second. The math is correct. Displacement is half acceleration times time squared, 187,000 kilometers. Significant changing orbit by hundreds of thousands of kilometers in celestial mechanics. Small changes accumulate large. But assumptions stack: acceleration maintained constant, vector correct, timing precise. Outgassing decreases far from sun. Force direction matters: tangential changes. Plane radial changes. Speed transverse changes. Orbit shape. Without vector prediction speculative. Earth moves 30 kilometers per second, needs sync for intersection. Energy huge if billions of tons natural or artificial. Perturbations from planetary radiation, solar wind, add uncertainty. Like driving on highway, accelerating but need direction, timing, exit. Correct delta V orbits more complex. Assumption of direction favoring Earth lacks evidence. Data shows acceleration, not vector intent. Each assumption a weak link chain, breaks collapse. No, acceleration exists, orbit close in December. Assumptions of prolonged correct direction, timing match without interference. Next examine real orbit misdistance. Real orbit part. Space agencies of Atlas flying by at 1.88 astronomical units, 270 million kilometers on the 19th of December. Twice perihelion distance from Sun. 30 times dangerous threshold of 7.5 million. No planetary defense threat. Misdistance from hyperbolic orbit compared to Earth's position. Delta 5, 86 meters second, shifts 187,000 kilometers, changes. Position but not enough from 270 million to 0, unless perfect direction. Velocity 60 kilometers second, change 0.15%. Needs larger delta V for precise collision alignment. Force direction decides perpendicular changes. Plane, longitudinal changes. Timing not guarantee closer. B-plane maps, intersection small change moves point hard to hit center unless specific force. No acceleration direction for Atlas, no predict miss change. Claims assume ideal direction. Large mass hard to control, natural massive loss. Artificial powerful engine. Agency models include non-grav perturbations, conclude safe. No alert. Delta V notable but full orbit context timing distance MSI shows distant pass. Atlas valuable science strange acceleration interstellar source. Earth targeting scenario speculative. Next observation campaign. Upcoming observation part. Next month's key Atlas type monitoring from now 2026. Perihelion 30th October, close Earth. 19th December limited window fades going out. Hubble visible UV imaging Webb infrared thermal gas dust. VLT Chile. Keck Hawaii contribute radio telescopes. Listen strange emission observations verify continued acceleration. Vector force surface components 1.4 GHz signal origin. Bright tail supports natural outgassing. Artificial structure complex signal opens other possibilities. New data confirm disprove speculation. Community follow continuous updates. Join official channel real progress. Progress connection part. Atlas link search for extraterrestrial life. AI fast data analysis radio, weak signal detection. New tech decodes mysteries fast. Oumuamua. Similar debate Borisov. Normal Atlas redefines interstellar visitors, whether comet or more drives exploration. Conclusion journey. 3I. Atlas. Real unusual acceleration distant Earth orbit. Calculations feasible change but many assumptions lack intent. Observations answer clear. Universe surprising. Atlas reminds stay open data-based. Follow results share knowledge. Thank you, accompanying vast exploration. Something is happening out there, a subtle orbit change that could be targeting our planet. 3I. Atlas. The visitor from a distant star system once seen as a directionless ice block is now speeding up along an unbelievable path. Assessments from multiple groups based on Loeb's report on non-gravity acceleration near perihelion, if extended 50 days speed change, 86 meters second, enough to sync with Earth on the 19th of December 2025. Natural physics or intentional thrust random dust sun or purpose. And along with it 1.4 GHz frequency with weak rhythmic pulses, nearly mathematical echoing through the void like a reply. Orbit signal combination suggests coordination. Leading scientists are whispering the unbelievable because 3I Atlas is not gliding past, it is approaching. If captivating, follow real-time updates like subscribe channel. Comment location local time thoughts developments. Share X Facebook Reddit chat groups help community. Thank you support pursuing story. Part 1 Breakthrough Discovery. Entity from another star system cutting across ours, between Mars Jupiter. Not guesswork fantasy it exists. Name Atlas discovered 1st of July 2025 by Misa Chile. Special not just origin but current behavior. X post. Spread shock calculation. If acceleration 0.02 mms, second squared 50 days delta vi. 86 mmHg second leading to Earth coincidence 19th December. Recall Earth coincidence. Posts push far. Not random but deliberate control. Mention 1.4 GHz. Ping communication adjustment handshake ship outside near Mars. Before dismiss conspiracy see known facts. Real hyperbolic orbit not sun-bound from interstellar. Perihelion 30th October non-grav acceleration reports. Means movement beyond gravity prediction. Non-grav not magic not fully understood. Orbit deviation has other force pushing. Often gas release comets ice vapor jet. Small force. 0.02. mh second squared small 1 over 150,000 Earth GTSAE, but space vacuum days weeks accumulate. Interesting third confirmed interstellar. First Oumuamua 2017 cigar-shaped debated Borisov. 2019 ordinary comet. Atlas 3 behavior, hard questions. Dangerous if anomalous comet science value piece other system clues. Planet formation galaxy. If acceleration intentional control. Different realm far-fetched possibility manufactured object other civilization. Investigation goal simple see claims. Data assumptions calculation speculation. Explore no guess toward end. 2025. Early 2026 observations confirm disprove. Not paranoia, understand real feasible noise. Universe full unknown occasionally challenges models. Atlas one of, or ordinary comet strange outgassing. End movie wonder natural comet probe middle. Judgment tools, science math observation broad implications. No pay attention next months. Structure 3 acts Act 1 claims data numbers assumptions. Earth intercept scenarios. Act 2 speculation debate natural strange explanations. Social stories amplified. Act 3 expand universe breakthroughs. AI radio connect Atlas advanced exploration. End unfolds continue attention. Universe not care comfort not ready revelations. Human history believes a lone Earth universe center spun around. Major discoveries humble steps. Earth orbits Sun. Sun billion stars. Galaxies countless objects other systems visit. Visitor action not easily explained. Next real data self-evaluate claims true thorough illusion. Part 2. Real data. Discovery. 3i Atlas 1st of July 2025. Asteroid impact Earth system Chile telescope network detect near-Earth objects unusual detection. Initially faint moving dot sky quick orbit calculation reveal extraordinary. Hyperbolic orbit not sunbound moves fast. Gravity cannot capture. Comes elsewhere passes our system leaves star void. Sign interstellar visitor. Third confirmed interstellar object. Speaking orbit perihelion closest. Sun 30th October 2025. Distance 1.36 1.4. AU Earth. Sun distance 150 million kilometers. Perihelion places Atlas 210 million kilometers from Sun near Mars orbit. Expected closest Earth 19th December distance 1.8. AU 270 million kilometers. Easy visualize Moon Earth 384,000 kilometers Atlas fly 700 times Earth Moon distance. Very far beyond usual close encounter definition. Now deep unusual phenomenon. Medium article Avi Loeb astrophysicist Harvard famous Oumuamua debated search alien tech reports anomaly. JPL astrometry data millimeter. Atacama. Array, orbit deviation expected object not position pure gravity. Deviation 4. Arc-second small angular shift significant tracking millions kilometers. Loeb calculates non-grav acceleration, approximate 0.02 mems second squared. Then apply momentum conservation equation cause. If outgassing kinetic stream vapor push high mass loss rate. Calculation at least 1/16th mass evaporate month create acceleration. Pause non-grav. Not strange. Comets experience often. Ice sublimate solid gas, escape surface push force. Like weak rocket measurable. Challenge Atlas scale. If mass large estimated billions tons 1/16th month loss creates spectacular gas, dust cloud smoke visible tail detected. Atlas images unusual features jet structures point sun instead away, not common. Color attracts reports greener than sun possible ionized carbon monoxide not usual dust. Clues, not conclusive. Strange comet interstellar stranger. Data not confirmed Loeb object aligns Earth. Not say deliberately moves us. Data acceleration deviation direction. Interesting happens. Leap Earth intercept deliberate from elsewhere social media takes Loeb numbers runs calculations. Key difference. Data compelling not unexplained. Hyperbolic interstellar object outgassing jet structure fits known physics. Unusual sure not impossible. Question data support bold 3. Atlas actively changes direction Earth or takes real data. Adds layers assumption shocking conclusion. So far confirmed interstellar orbit relatively close Earth distant. Non-grav acceleration outgassing other cause. Math calculation small continuous thrust 50 days lead significant velocity change. Enough claim alignment. Question address next math assumptions turn data narrative. Part 3. Extrapolation Earth cut. Math assumptions. Do calculation. Social claims classical physics equation. Acceleration time velocity change. Constant acceleration 0.02. Second squared 50 days. 50 days. 4,320,000 seconds. Multiply 0.02 a minute or second squared 210 minus 5 second squared result approximate 86.4 meter second. Delta phi velocity change. Calculation correct, no arithmetic debate. Speaking displacement. Apply constant acceleration time, not only velocity change, position change. Displacement constant acceleration, half acceleration time squared. Plug numbers half 2. 10 minus 5. By second squared 4.3210. 6 squared seconds result 1.8710 m. 187,000 kilometers. Nearly half Earth-Moon distance. Number not trivial. Small continuous thrust 50 days shifts object orbit hundreds thousand kilometers. Orbital mechanics context important. Position change specific time plane cut. Changes missed distance. Theory flyby far closer, but assumption stack. Calculation assumes acceleration continues undiminished 50 days. True unknown. Acceleration measured specific point near perihelion. Extends weeks, months unclear. Outgassing changes. Sun distance. Far perihelion. Sun heat decreases, sublimation decreases. Thrust weakens, stops. Calculation assumes correct acceleration vector. Direction matters, magnitude. Tangential thrust orbit. Earth changes orbit plane, not significantly missed distance. Thrust forward increases, speed changes. Arrival time. Backward slow same. Radial push away. Sun changes semi-major axis, eccentricity. Unknown acceleration direction integrating velocity change. Predicting orbit speculative. Timing assumption another important. Object applies thrust correct moment direction path cuts. Earth orbit, when Earth actually there. Earth velocity 30 kilometers second around Sun. Moves far day. Hitting moving target demands precise timing navigation. 187,000 kilometers shift moves. Intersection point. But Earth not there. Time overlap not happen. Continue energy mass issue. Object mass estimated billions tons maintaining thrust enormous energy. Natural outgassing high mass loss rate low calculated. Artificial long-term propulsion system. Both scenarios difficult without supporting evidence. Finally, perturbations. Space not empty. Solar radiation pressure planetary gravity solar wind. Yarkovsky effect affects small object orbits. Simple calculation assumes negligible average. Reality noise uncertainty. Exact 50-day burn idealization. Comparison highway driving. No accelerate 60 km/h current speed. Like delta V, but merge correct time specific exit more than speed. No exit speed moving traffic time accelerate steering direction. Arithmetic velocity change story. Geometry timing. Orbital mechanics different story. Social extrapolation assumes acceleration acts beneficial direction arranges Earth. No evidence. Data acceleration vector versus Earth orbit. Claims add purposeful acceleration targeting Earth. Interpretation stacks data, not infer data. No versus assume. No small measured non-grav acceleration. No orbit brings close Earth December. Assume acceleration lasts 50 days. Assume correct direction. Assume timing coincides. Assume no interfering factors interpret deliberate maneuver toward Earth. Each assumption chain link. Break link claim collapses. Issue not math correct. Correct. Issue real world follows assumptions. Continue examine real orbit missed distance. The 86 meets a second shift actually changes 270 million kilometer flyby something concerning. Part 4. Object orbit missed distance. Official figures clear. NASA ESA. 3i Atlas flies past Earth, approximate 1.88 AU, 19th December 2025. Distance equivalent 270 million kilometers. Easy visualize. AU. Average Earth, Sun 150 million kilometers. 1.88 AU object nearly twice closest Sun distance. Distance not close. Not planetary defense standard. Dangerous objects orbit within 0.05 AU, 7.5 million kilometers. 3 Atlas passes more than 30 times threshold. NASA ESA clearly state object no threat Earth. Missed distance orbital mechanics operation. Object hyperbolic approach path. Determined velocity direction gravitational influences. Missed distance closest point calculated object orbit versus Earth position specific time. Atlas calculation 1.8 AU 19th December. Addressment question. 86 m/s velocity change significantly alter missed distance. Answer yes, no context. Yes, principle 86 am/s delta vi. Applied 50 days shifts orbit. Hundreds thousand kilometer previous calculation 187,000 kilometers. Number not small. Orbital mechanics small velocity changes create large position changes. Time especially applied early orbit phase. But not turn 270 million kilometer miss Earth collision needs far more than 86 m/s unless vector timing extremely favorable. Object moves 60 km/s, 60,000 ms/s. 86 ms/s small 0.15% total velocity. Orbit change enough shift miss distance from 270 million km to 0. Needs much larger delta V. Near perfect alignment thrust direction timing. Thrust direction everything. Imagine object orbit straight line through space. Sideways push perpendicular velocity vector changes orbit plane. Shifts path 100,000 km sideways, not necessarily closer Earth. Forward backward push. Along velocity vector changes arrival time. Object reaches Sun-Earth plane earlier later not guarantee closer unless Earth coincidentally correct position. Radial push away. Sun changes orbit shape eccentricity perihelion distance. Orbital mechanics concept B-plane. Imaginary plane perpendicular incoming orbit calculates object position target intersection. Imagine dartboard. Bullseye Earth. Object orbit pierces plane somewhere distance bullseye point miss distance. Small velocity change moves. Object position cutting plane moving edge outside board bullseye demands specific thrust. Unknown non-grav acceleration direction 3i Atlas versus Earth position cannot say actual miss change how much. Social claims correct thrust direction. Large assumption. Mass issue object. Estimated 3 Atlas large, heavier 33 billion tons, diameter few kilometers. Controlling size difficult if natural outgassing mechanism. Intentionally steer mountain evaporating surface ice. If artificial implies extreme power propulsion system. Physics challenging. NASA ESA scientists full data access orbit modeling. Conclude object no Earth intersecting orbit. Account uncertainty perturbations potential non-grav forces. Model safe path. If numbers showed otherwise small collision chance alarm bells ring. Planetary defense network exists identify track dangerous objects. 3 Atlas not threat list. Reality check miss distance leads this. Shape timing. Earth collision scenario phase unlikely happen. Object needs much larger velocity change. Specific direction specific time. Turn 270 million km flyby. Something dangerous. Numbers alarming focus delta V. Full orbital mechanics context timing miss distance only shows distance safe pass. Not mean object not interesting. Absolutely not. Non-grav acceleration unusual feature interstellar visitor all immense science value. But Earth intercept scenario claiming coincidence is still speculation. Continue learn ongoing observation campaign. Powerful telescopes aimed. 3i Atlas, predict verify. Soon reveal. Object comet probe. Middle. Part 5. Observation Campaign Predict Verify. Next few months critical time. From now, early 2026 3. Atlas closely monitored. World Ground Space Telescopes track. Moves perihelion 30th October 2025. Object closest Sun. Then outward approaches Earth 19th December. Observation window not forever. Object moves past Earth, deeper outer solar system fades view. Main campaign instruments most powerful humanity built. Hubble Space Telescope high-resolution images visible ultraviolet wavelengths. James Webb Space Telescope infrared capability, detect heat signs, analyze gas-dust composition surrounding object. Ground observatories. Very Large Telescope VLT Chile. Keck Observatory Hawaii contribute. Radio telescopes listen unusual emissions. Mars orbit probes glimpse 3A. Atlas flyby, relatively near red planet. Interesting coincidence 4th November 2025. Jupiter icy moons explorer JUICE flies past within 64 million km 3I Atlas. Distance not close enough. Dedicated flyby JUICE instruments collect data distance. All information useful. Other researchers make testable predictions. Predictions depend non-grav acceleration, natural outgassing, other cause. If outgassing cause significant mass loss. Lobe calculation at least 1/16th mass evaporate month. Create huge gas dust cloud outer shell visible tail extended behind object solar wind pushes particles away. First simple prediction. Natural acceleration telescopes detect large gas dust envelope. Spectroscopy presents volatile substances. Water, carbon monoxide, carbon dioxide, methane. Object active comet typical sublimation signs. But no large cloud, minimal mass loss. Natural outgassing hypothesis weakens. Significant result. Means acceleration something else not require ejecting large material. Then non-natural technology explanations more reasonable. Follow-up measurements. Astrometric residuals difference actual object position versus pure gravity model prediction. Residuals reveal magnitude direction non-grav force. Coming weeks more observations astronomers refine orbit, quantify acceleration more precisely. Spectroscopy key tool. Breaking object light wavelengths components. Scientists identify present molecules atoms. 3 Atlas recorded unusual colors described greener sun. Indicates ionized carbon monoxide sign. Type comet different meaning. Detailed spectral analysis no more composition matches known comet chemistry not. Imaging important. Morphology coma. Comet tail jet structures presence asymmetry provide clues. The report mentions a tail with reverse jets pointing toward the sun instead of away. This is unusual but has occurred before. Comets sometimes show forward-facing features due to rotational geometry. High-resolution images will clarify if this fits natural processes or not. Beyond optical astronomy, radio astronomy plays a role. Social media posts claim the object is sending a 1.4 GHz ping signal for communication to adjust its flight path. This is completely unverified. Radio telescopes are listening. Any unusual emission even at 1.4 GHz or other frequencies would be detected and analyzed. Radio signals from comets are rare and usually occur from plasma interactions. A structured strong signal is an entirely different matter. The observation campaign faces challenges. Timing and shape are critical around perihelion. The object near the sun makes sky observation difficult due to solar glare. Now moving away from the sun toward Earth, the line of sight improves. By late December, the close approach begins, but it starts fading as it moves away from the sun and Earth. The window is short. Weather telescope availability, funding, and coordination play important roles. Not every telescope observes every night. Data is collected, analyzed, peer-reviewed, and published. Science moves slowly compared to social media. Claims spread in hours. Observations take weeks or months to confirm or refute. Yet this is an exciting time. Following an interstellar visitor in real time. Telescopes that observe exoplanets and probes analyzing exoplanet atmospheric chemistry are now pointed at this object passing through our neighborhood. A rare convergence of opportunity and technology. Early 2026 will bring answers. If 3I Atlas maps as an active comet, massive outgassing comet, head comet, tail spectral signs of volatiles, the natural explanation holds. Non-gravitational acceleration is the comet doing strong but normal comet things given its interstellar origin and composition. But if observations show minimal mass loss, no significant cloud continued acceleration or inconsistent jet directions, problems arise. Not a catastrophe. A scientific puzzle that doesn't fit models. Then the story shifts. Then strange hypotheses, not mere speculation, demand serious consideration. The next part dives deeper into the debate natural versus non-natural, the role of social media amplifying claims, and what it means if 3I Atlas turns out to be something other than a comet. Part 6. Non-gravitational acceleration, natural explanations. Comets are dirty snowballs, at least that's the simplified astronomy intro version. A comet's nucleus is a mix of ice rock and organic compounds. Near the sun, solar radiation heats the surface. Ice sublimates from solid to gas without a liquid phase. Escaping gas carries dust particles, creating a cloud coma and a tail that extends away from the sun. Outgassing creates spectacular sights and thrust. Gas molecules carry momentum. Leaving the comet nucleus pushes the comet backward like a punctured balloon flying across a room. The effect is small but measurable. Called non-gravitational force, astronomers have detected and modeled it for decades. Avi's report of non-gravitational acceleration at 0.02 mm per second squared for 3I Atlas assumes first gas release. The default hypothesis is the most natural explanation. Details matter. Loeb applied the momentum conservation equation to estimate the mass needed to produce the acceleration. The formula is simple. Force on the comet equals mass loss rate times exhaust gas velocity. Force also equals mass times acceleration. Rearrange to find mass loss rate. Exhaust velocity for comet jets is typically a few hundred newtons per second. With acceleration 0.02 newtons per second squared, calculate the comet's mass loss rate. The result is staggering. If 3I Atlas has a mass of about 30 billion tons, the calculation shows losing around 5 billion tons per month to sustain the acceleration. That's equivalent to 1/16 of its total mass in 30 days. A few months and the comet evaporates a significant fraction of itself. Such large mass loss would be visibly obvious. Astronomers would see a gigantic gas and dust cloud enveloping the nucleus. A prominent comet tail. Spectroscopy would reveal abundant volatiles. Yet observations so far are more subtle. Reports note jet structures pointing toward the sun. Unusual object color greener than expected. A massive gas cloud corresponding to that mass loss level has not been clearly observed. That doesn't kill the natural explanation. Comets are diverse. Outgassing can occur in bursts as rotation exposes fresh ice layers, or surface layers collapse. High mass loss rates can be temporary, peaking near perihelion and subsiding after. Gas escape in focused jets rather than uniform dispersion makes the gas cloud harder to see from Earth. Transparent gas without much dust reduces visibility. The greener than sun color is interesting. It points to ionized carbon monoxide dominating the spectrum, a type of comet. Carbon monoxide ice sublimates at lower temperatures than water ice at greater distances from the sun. Interstellar comets may have different compositions than solar system comets rich in carbon monoxide. Exotic ices formed in a different stellar environment. Images show the reverse tail phenomenon, features pointing toward the sun instead of away. Rare, but not impossible. It occurs due to observational geometry, viewing the comet at an angle where dust in the orbital plane appears forward-facing, or real forward-pointing jets driven by localized thermal rotation. A natural explanation requires all factors to align. Large mass loss, unusual composition, bursty outgassing, geometric effects. The picture is complex. Comets are complex objects. They don't always behave the same. Interstellar comets formed in another star system under different conditions are likely to deviate from solar system comet models. Beyond that, the size and mass of the object. Estimated diameter at least a few kilometers, possibly more than 5. Mass exceeding 30 billion tons. A large comet. Accelerating such a large object via outgassing requires enormous energy and material. Like trying to push a cargo ship by throwing cargo overboard. It can be done, but you have to throw a lot of cargo fast. The analogy is useful. Imagine a giant container ship losing half its cargo in a month to gain a little speed. Feasible but traumatic. You'd see containers floating everywhere. A debris field is evidence of loss. Similarly, if 3I Atlas loses 1/16 of its mass in a month, we should see evidence. Gas dust, a glowing envelope. Satisfying the natural explanation means detecting a large cometary envelope matching the predicted mass loss rate. Spectroscopy confirming the presence of water, carbon monoxide, carbon dioxide, and other volatiles in expected amounts. Images capturing classic comet tail structures with multiple jets. Most importantly, acceleration correlating with the comet's distance from the Sun. As it moves past perihelion, solar heating decreases. Outgassing weakens, acceleration drops. If acceleration persists or increases far from the Sun warning sign. For now, the outgassing hypothesis is reasonable and debated. The required mass loss rate is high. Observational evidence is ambiguous. The object's size and mass make the story harder to swallow. Comets have surprised us before. Oumuamua surprised with acceleration and elongated shape. Borisov surprised by looking completely normal. 3I Atlas is the next surprise. A comet with extreme characteristics pushing the boundaries of normal. Or something entirely different. That's what the next observations will reveal. Strange technology hypotheses sit at the boundary of speculation and science. Part 7. Non-gravitational acceleration. Strange technology hypothesis. What if the acceleration isn't natural? What if 3I Atlas isn't doing what a comet does? What if it's something designed, something sent design? How Avi and colleagues published a paper titled, Could the Interstellar Object, 3I Atlas be extraterrestrial technology, not a joke? A serious scientific investigation in the context of elimination. The paper explores the possibility that the object is an artifact or probe from another civilization. Why propose it? Several factors converge. First, the non-gravitational acceleration. Without outgassing, the outgassing explanation is hard to believe. The required mass loss rate needs an alternative mechanism. Second, estimated size and mass. A large massive object undergoing measured acceleration implies significant energy and momentum transfer. Third, the orbit. Loeb notes the object's path through the inner solar system timed to align with Earth's orbital plane is statistically unusual. Not impossible, but a random interstellar visitor is unlikely. Energetics are worth exploring. An object with tens of billions of tons of mass sustaining 0.02 mm per second squared acceleration for weeks. The required thrust is large. Force equals mass times acceleration. Plug in 10 to the 13th kilogos times 2 times 10 to the minus 5 m per second squared force around 200,000 newtons. Thrust like a small rocket engine continuously accelerating, but a solar sail wouldn't be efficient unless very large with high reflectivity. Calculations for a sail large enough to accelerate a kilometers-wide mass require precise orientation. Or something stranger, an ion engine fusion engine technology not yet invented. The 1.4 GHz ping mentioned in social posts adds a layer to the theoretical hypothesis. 1.4 GHz is significant in SETI. It corresponds to the hydrogen line, the natural frequency of neutral hydrogen atoms. Sometimes called the water hole in radio astronomy, a quiet band in the electromagnetic spectrum, where signals can travel space with minimal noise. If an advanced civilization wanted to send a signal, 1.4 GHz is a logical choice. But the issue is no verified public detection of such a signal from 3I Atlas. Radio telescopes constantly monitor the sky. A strong structured signal from the object would definitely be noticed. The claim is unproven speculation. Yet consider the hypothesis. Suppose 3i Atlas is an artificial probe, purpose reconnaissance observation, perhaps drifting through space for millions of years, a relic of a long-dead civilization still executing a pre-programmed mission to survey star systems, or active, deliberately adjusting course to study an interesting target. Self-navigating to intercept Earth short, answer unlikely. A probe with a propulsion system could change orbit, but the delta V needed to turn a 270 million kilometer miss into an intercept is realistically many times larger than 86 newton per second. It would need velocity changes on the order of kilometers per second applied over the right time and direction. Large sustained thrust. Loeb discusses the dark forest hypothesis in relation to 3i Atlas. The idea popular in science fiction by Liu Cixin is that the universe is full of civilizations staying silent to avoid detection by potential enemies. Revealing presence leads to destruction. Everyone stays quiet, hiding in the dark forest of the universe. Loeb speculates that if 3i Atlas is a probe, its behavior reflects a cautious approach, observing from afar rather than direct contact. Highly speculative. Many layers of assumptions stacked. Assumption 1. Acceleration not natural. Assumption 2. Artificial. Assumption 3. Intelligently controlled. Assumption 4. Intelligence cautious and purposefully approaching Earth. Each assumption reduces the overall scenario probability. Clear evidence of technological origin. Unexpected radio emission, especially a structured signal containing information. Signs of thrust without vaporization, sustained acceleration without corresponding mass loss or gas release. Extremely low mass loss with high acceleration violating rocket physics and less external energy source. High surface reflectivity suggesting engineered material rather than natural rock and ice. Attitude changes or orientation not explained by tumbling or spinning. If observations detect any of these, the conversation changes immediately. Suddenly, the strange hypothesis is not fringe speculation, a viable explanation demanding investigation. But without such signs, if the object continues to behave like a strange natural comet, the technology hypothesis gradually fades into obscurity. The stakes are high. If the probe scenario is correct, it confirms we are not alone. It means another civilization achieved the technology to send objects across interstellar space. It raises questions of intent, longevity, fate. Are they still out there? Did they send 1,000 probes? Is 3i Atlas ancient or recent, but high stakes don't mean the hypothesis is true. Extraordinary claims require extraordinary evidence. Current evidence is ambiguous. Non-gravitational acceleration is real, but not conclusively non-natural. The orbit is somewhat unusual, but not impossible for a random interstellar object. The radio signal is unverified. No large cometary cloud suggests no conclusion yet. Science proceeds by testing hypotheses, making predictions, comparing to observations. The technology hypothesis makes predictions. No large gas cloud means no outgassing. Acceleration sustained as the object moves far from the sun, thrust not created by the sun. Possible radio emission or other non-thermal signs. The next few months of observations will test these predictions. If the object is natural, priceless learning, pushing the boundaries of comet science, exploring the chemistry and dynamics of interstellar visitors, testing models in extreme cases. If the object is artificial, the greatest discovery in human history. Either way, observations in late 2025 and early 2026 are riveting. Next, see how the story spreads. How social media takes scientific data and turns it into an alien intervention conspiracy. Part 8. The social media story and conspiracy building. Posts appeared on X in mid-December 2025. An independent researcher not affiliated with major organizations made a series of claims. The core is simple. 3i Atlas is accelerating. If it continues accelerating at 0.02 mm per second squared for 50 days, it reaches a velocity of 86 meters per second. That velocity change applied in the right direction at the right time puts the object in alignment with Earth on the 19th of December 2025. Then the claims escalated. The researcher said the acceleration is not random, it's intentional. The object is moving and adjusting course toward Earth. Information mentioned a 1.4 GHz ping detected near Mars. Communication for a related handshake with another object. The story shifted from an interesting scientific phenomenon to an alien probe targeting us. Break it down piece by piece. The acceleration data part is real. AV reported it based on reliable astrometric observations. The arithmetic calculation 0.02 mm per second squared times 50 days equals 86 mt per second. Correct. Basic physics. No error. But the assumptions. Assumption that acceleration lasts exactly 50 days. Assumption of direction toward Earth. Assumption of timing perfectly matching Earth's orbital position. None of the assumptions are verified. The inference is guesswork based on limited data. The interpretation claims the object will align with Earth. The data ends and the story begins. Alignment implies intent. Implies the object is self-navigating with purpose toward our planet. No evidence. The missed distance remains 270 million km. NASA says no threat. Geometry does not support an intercept scenario unless many implausible factors align. The 1.4 GHz ping is unverified. No major observatory has confirmed radio emission from 3I Atlas. If the signal existed, radio astronomers would investigate. Lack of confirmation doesn't prove the ping doesn't exist, but it means don't take it seriously without evidence. How did the story gain traction? Social media thrives on uncertainty and drama. An unusual scientific phenomenon with gaps in understanding is fertile ground for speculation. People take the data, add their own interpretations, and create narratives. Narratives spread faster than science and are more engaging. An alien probe targeting Earth is more compelling than an unusual outgassing comet. The psychology is fascinating. Humans are pattern-seeking creatures. We see connections that aren't there. We're drawn to stories that impose meaning on chaos. An interstellar object with unexplained acceleration is not a comet behaving oddly. It's a sign, a message, even a warning. The claims fit into larger cultural anxieties about the unknown, what's out there, whether we're ready for contact. Conspiracy theories amplify it. The seed is planted that the object is artificial. Every ambiguity becomes evidence. No clear comet signs means evidence it's not a comet. Unusual color means engineered material. Targeted orbit means purposeful. Lack of official signal confirmation means cover-up. Clearly, the story self-reinforces without contradiction. This isn't unique to 3I Atlas. Oumuamua went through a similar cycle. Strange object appears, scientists admit not fully understood, internet fills the gap with aliens. Sometimes scientists like Avi fuel it by openly considering strange hypotheses to examine all possibilities, including technological origin. Open-mindedness is scientific virtue but provides fodder for sensationalism. Mainstream media reports simplify and exaggerate. Clickbait headlines about alien probes while the article is more cautious. The New York Post ran a story quoting Loeb calling 3I Atlas a potential alien engine. Framing matters. Most people don't read past the headline. They absorb the idea that a scientist says it could be alien, and it becomes the story. Responsibility lies with science communication to distinguish what the data shows versus what someone infers. The data shows non-gravitational acceleration period. The inference is Earth intercept purposeful control alien technology. Inferences stack. It could be true but isn't established fact. Consider this. On one hand, don't rush to dismiss possibilities. Science advances by considering ideas that seem impossible. On the other hand, don't treat speculation as evidence. The claim that 3I Atlas will align with Earth is not on the same footing as the observation of non-gravitational acceleration. One is measured, the other is inferred. Social media blurs the distinction. Everything becomes a claim, a theory, a possibility. The signal-to-noise ratio drops. People argue whether the object is a threat without agreeing on what the actual data says. Misinformation spreads not because people lie, but because the boundary between data and interpretation blurs. It raises metaphysical questions. Are we ready for the possibility? If the object is natural but truly strange, pushing the boundaries of normal physics, what then? If artificial confirming were not alone, what then? How does society handle information in a context where facts and speculation come from the same feed? The 3i Atlas social media narrative is a case study in the intersection of science and storytelling. The next part explores what happens if the story turns out to be more than a story, if the object actually does something unexpected. Part 9, what if intercept worst-case hypothesis? Let's do a thought experiment. Analyze the scenario, not predict it. What happens if all assumptions are correct? What happens if 3i Atlas maneuvers enough to intersect Earth? What does that mean? First, the parameters. Estimated size of 3i Atlas ranges from a few hundred meters to a few kilometers in diameter. Brightness and reflectivity calculations assume broadly up to 5 kilometers or larger. Mass estimated to exceed 30 billion tons, possibly more. A mountain hurtling through space. Interstellar objects move very fast, entering the solar system on a hyperbolic orbit unbound by the sun's gravity. They don't slow much. 3i Atlas is moving at about 60 km per second, 60,000 m per second, over 130,000 miles per hour. That speed means tremendous kinetic energy. The formula for kinetic energy is simple. Energy equals 1/2 mass times velocity squared. Use conservative estimates. Assume mass 30 billion tons, 3 times 10 to the 9th kilogram. Velocity 30,000 m per second as a midpoint estimate. Plug in the values. 1/2 times 3 times 10 to the 9th kilogauss times 9 times 10 to the 8th m per second squared. Energy, 1 ton of TNT releases 4.2 times 10 to the 9th joules. Divide the kinetic energy. The result is about 3.2 million megatons, 3 million megatons. For comparison, the largest nuclear weapon ever tested, the Soviet Tsar Bomba, had a yield of 50 megatons. An impact would be over 60,000 times more powerful. The consequences would be catastrophic. An object of that size and speed would punch through the atmosphere in seconds. No time for significant deceleration or burn-up. It would hit the surface at nearly maximum speed, releasing all its kinetic energy in an instant. An explosion dwarfing anything in human or natural history. A firestorm igniting across continents. Shock waves leveling everything for hundreds of kilometers around the impact site. Earthquakes rippling through the crust. If it hit, the ocean tsunamis 1,000 meters high, moving at jet speeds across ocean basins. Coastal cities wiped out. Immediate destruction is just the beginning. The energy would vaporize the object and the impact site, hurling massive amounts of rock, soil, and water into the atmosphere. Dust and aerosols would spread globally within days, blocking sunlight. Temperatures would plummet. Photosynthesis would halt. Crops would fail. Famine would kill far more than the initial impact. An extinction-level event, not necessarily wiping out all life. Earth has survived worse, but extinguishing most large animal species, including humans. The scenario is equivalent to the impact that killed the dinosaurs 66 million years ago. Now consider a less extreme case. Suppose 3i Atlas doesn't hit Earth but flies by much closer than predicted 1.8 AU. Suppose it passes within tens of thousands of kilometers near geostationary satellite distance. What happens? A close flyby would be impressive. The object's gravity would perturb Earth's orbit, slightly imperceptible. Earth is far more massive. The effect would be tiny. Electromagnetic or plasma interactions could be interesting. If the object carried a magnetic field or charged particles, it could trigger auroras, temporary radio disruption, satellite interference. Beyond that, debris issues. If 3i Atlas is shedding material through outgassing or fragmentation, a close flyby could bring dust and particles into Earth's atmosphere. Enhanced meteor showers. Spacecraft in low Earth orbit at risk of collisions. The International Space Station satellites, everything in orbit, would need monitoring. Scientifically, a close flyby would be a bonanza. Telescopes would collect unprecedented resolution data. Radar would map the surface. Spectroscopy would analyze composition in detail. If the object turned out to be artificial, evidence would be undeniable at close range. Back to the main question. How much delta V is actually needed to turn the predicted missed distance into an intercept missed distance 270 million kilometers? Closing that gap requires significant orbital change. 86 inches per second is not enough unless the geometry is extraordinarily favorable. Let's rough estimate. Object velocity 60 km per second. A 1% velocity change is 600 km per second. That shifts the impact parameter by a few million kilometers depending on direction and timing. Shifting 270 million kilometers requires changes of several kilometers per second over many weeks or months in the right direction. That doesn't happen with 0.02 mm per second squared over 50 days. It would need much stronger acceleration sustained longer and applied earlier in the orbit. The numbers do not support an intercept scenario based on the reported acceleration. The worst-case hypothesis is terrifying. The chain of assumptions needed to reach it is long and fragile. The object would need a propulsion system capable of generating extreme thrust. It would have had to start maneuvering many months or years earlier, not just near perihelion. It would need precise information on Earth's position and velocity. Even the energetics are daunting. If the object is artificial and targeting Earth, what purpose observation is the most rational? Why send a probe across interstellar space to destroy via impact? A flyby makes more sense. Get close enough to study the planet atmosphere, biosphere, even technological signatures, then continue. Or it's not targeting Earth at all. The orbit is random, a product of dynamics from its origin system. Reading intent into randomness is seeing patterns that aren't there. Monitoring or defense options currently not many. Planetary Defense has tested deflection, the NASA DART mission on Dimorphos, designed for small, slow objects detected years in advance. An incoming interstellar object moving 60 km per second detected only months before closest approach is beyond current interception capability. Early warning networks are useful. Detecting objects years in advance gives time to plan missions, even interception or study. But 3I Atlas III was detected in July 2025, only months before perihelion and Earth approach. Not enough lead time for a deflection mission. The worst-case scenario pushes preparation but doesn't define the current situation. In reality, 3I Atlas is not a threat per reliable orbital calculations. The missed distance is comfortably large. The orbit is well understood. Agencies tracking it have issued no warnings. Next, broaden the scope to consider wider impacts of interstellar objects on planetary defense and studying other solar systems. Part 10. Broader impacts interstellar objects planetary defense. 3I Atlas is the third confirmed interstellar object detected. The first, Oumuamua, was discovered in October 2017. The second, Borisov, found in August 2019. Before that, no direct evidence of bodies from other star systems visiting ours. Now we know visits are more frequent than thought. Studying interstellar objects opens a unique window into the universe beyond the solar system. Fragments of other worlds, scraps of planetary systems light years away, delivered to our doorstep. Analyzing composition, structure, behavior reveals the chemistry and dynamics of star systems we'll never visit. Oumuamua was the mysterious first. Elongated shape, tumbling motion light. Non-gravitational acceleration sparked endless debate. Comet, asteroid, or something else, spectroscopy showed no cometary coma or tail. No clear outgassing signs, yet acceleration increased as it moved away from the sun, force beyond gravity. Avi famously proposed a light sail, a thin reflective sheet pushed by solar radiation. Most astronomers disagreed, proposing a comet with unusual properties, hydrogen or nitrogen ice sublimating without a visible cloud. Borisov was different. It looked like a normal comet. It had a coma, a tail, spectral signs of water and carbon monoxide. It behaved exactly as expected for an icy body passing close to the sun. In many ways, Borisov was reassuring. It showed not every interstellar object is weird. Some are comets from elsewhere. 3I Atlas sits between the two extremes. It shows cometary features but anomalies that don't fit standard models. Stronger than expected non-gravitational acceleration for its size. Extremely high mass loss rate if outgassing. Color possible, reverse tail, add quirky points. What do we know about interstellar objects in general? They are highly diverse. We cannot assume they all behave like solar system comets or asteroids. Composition, structure, history differ depending on where they formed. The dynamics of interstellar objects challenge our understanding. How frequent are visits? Where do they come from? Objects ejected from planetary systems by gravitational interactions with giant planets. Remnants of star formation leftover material that never coalesced into planets. Detection rates suggest interstellar objects pass through the inner solar system more often than previously thought. Better telescopes and more sky surveys find them. 3I Atlas was discovered by the same near-Earth asteroid search system. Future surveys like the Vera C. Rubin Observatory will detect many more. Finding 1 or 2 per decade is likely. This brings up the concept of planetary defense. Though 3I Atlas is currently no threat, a future object could come closer. Detection and response capabilities need improvement. Defending against interstellar objects is harder than solar system objects for several reasons. First, speed. Interstellar objects move much faster, tens of kilometers per second instead of a few kilometers per second. Less reaction time. Deflection is harder. Second, unpredictability. Their orbits are unknown until they arrive. Solar system objects follow predictable orbits tracked for years. Interstellar visitors appear suddenly. Third, limited observation time. They zip through and vanish from view. Only a few months to study. Mission design is crucial, detecting an interesting interstellar object years before closest approach. Could we send a spacecraft to intercept? The answer might depend on the orbit and readiness. The European Space Agency's Comet Interceptor mission is designed for rapid response to transient targets. Multiple such missions pre-positioned in space awaiting a target could revolutionize our ability to study interstellar visitors. Advanced radar, alongside optical tracking, helps. Better astrometry means more precise orbits, earlier detection of potential threats, and better characterization of noteworthy objects. Artificial intelligence assists in sifting massive datasets, flagging anomalies, and predicting orbits. Beyond tech aids, modeling high-velocity objects improves understanding of impact physics with applications in materials science and planetary geology. Tracking faint, fast-moving objects pushes the limits of instrumentation and data processing. Advances benefit not just planetary defense but astronomy in general. Now consider the implications if 3I Atlas turns out to be artificial. The impact on the search for extraterrestrial intelligence would be enormous. SETI has been listening for radio signals for decades, searching for deliberate transmissions from other civilizations. But an interstellar probe, a physical object sent across the galaxy, represents a different mode of communication and exploration. It suggests a civilization capable of building machines and launching them into space, leaving artifacts behind. If 3I Atlas is natural but strange, the implications for solar system formation and exosolar chemistry are still huge. It means the diversity of small body physics is greater than understood. Comet and asteroid models need to account for a wider range of compositions and behaviors. Either way, 3I Atlas is a wake-up call. Whether the story ends with a confirmed comet or a revolutionary discovery, the object reminds us the solar system is not isolated. The galaxy is vast with countless stars and planets. The space between is not empty. Objects drift, collide, get ejected, and wander. Some end up here. Public fascination with an alien probe draws attention and funding to space science but risks misunderstanding. Planetary defense agencies managing data narratives, providing accurate information and acknowledging uncertainty. The line between responsible speculation and sensationalism is thin. Scientist Avi walks a careful path, arguing openly for all possibilities. Critics say introducing strange hypotheses without enough evidence erodes public trust in science. The debate is healthy. It reflects the tension between caution and curiosity, conservatism and imagination. 3I Atlas. Whatever the outcome embodies that tension. Next, shift to recent breakthroughs in related fields of space science tied to the story. Part 11: Recent Breakthroughs in Exoplanet Atmosphere Imaging. 2025 has been a golden year for exoplanet science. The James Webb Space Telescope, launched late 2021, spent years calibrating instruments and targeting distant worlds. This year recorded something extraordinary. Detailed molecular signatures in the atmosphere of a Neptune-like exoplanet, orbiting a star 60 light-years away. The planet, designated K218b, was studied before, but JWST's infrared capability allowed astronomers to probe deeper than ever into its atmosphere. Spectroscopy revealed water vapor, methane, carbon dioxide, and traces of dimethyl sulfide, a molecule on Earth produced mainly by biological processes. The detection is tentative, needing many more observations to confirm, but if true, it's the first potential biosignature in an exoplanet atmosphere. Why relevant to 3I Atlas? The same techniques analyzing exoplanet atmospheres apply to studying cometary gas jets and outflows. Spectroscopy, the method of splitting light into wavelengths to identify components, tells what molecules are present. Whether looking at a planet 40 parsecs away or a comet 2 astronomical units away, the method is the same. We live in an era of observing the atmospheres of distant worlds and analyzing the chemical makeup of interstellar visitors. The tools overlap. Instruments checking exoplanets during transits across their host stars can be pointed at Atlas to analyze gas clouds and jets, what gases are being released. The exoplanet results in 2025 highlight the power of modern astrochemistry. Decades ago, exoplanets were barely detected, let alone their atmospheres described. Now we identify individual molecules, assess habitability, and search for signs of life. Similar capabilities apply closer to Earth. 3I Atlas provides a sample of extrasolar material, direct probing of another star system's chemical composition. Its anomalous features, acceleration, unusual color, possible reverse tail make it an enigma. If the composition turns out exotic, rich in molecules not seen in known solar system comets, it reveals the diversity of planet formation processes across the galaxy. The interdisciplinary nature of the work is astounding. Planetary science, astronomy, instrumentation, chemistry, physics all converge. Scientists analyzing exoplanet spectra collaborate with those studying 3I Atlas. The same telescopes serve dual purposes. Consider a specific case. Detecting water vapor and methane in K2-18b's atmosphere involved multiple transits of the planet. Each transit provided a spectrum showing wavelengths absorbed by the atmosphere. Comparing spectra, astronomers identified absorption lines corresponding to specific molecules. The precision required is immense, detecting parts per million in an atmosphere hundreds of trillions of kilometers away. Could similar techniques detect artificial signs in 3I Atlas? Possibly. If the object had a metallic surface or engineered materials with unusual reflectivity, spectroscopy would detect it. Metals have distinct spectral signatures. A surface coated in aluminum or steel reflects light differently than rock and ice. Polymers, ceramics, or other synthetic materials leave spectral traces. If 3I Atlas were a probe-type spacecraft, its surface materials would reflect its origin. A natural object would show silicates, organics, ices. An artificial one might include alloys. Composites, coatings designed for space durability. Differences detectable assuming high-resolution spectra. Telescopes scanning distant worlds help scrutinize a closer interstellar intruder. JWST, Hubble, ground-based observatories with adaptive optics all contribute. The interplay between exoplanet science and solar system science is an underappreciated aspect of modern astronomy. Beyond that philosophical links, studying exoplanets is about understanding our place in the cosmos, searching for other worlds that might harbor life. Studying interstellar objects is encountering fragments of those worlds, welcoming visitors from systems we'll never reach. Both efforts point to the same question: are we alone? If 3I Atlas is natural, it's still an emissary from another star carrying information about its birthplace. If artificial, the implication is explicit. Either way, it ties into the broader search for life and intelligence beyond Earth. Next, consider recent discoveries in dark matter and modified gravity theories that might relate to interpreting anomalous accelerations in small bodies like 3I Atlas. Part 12. New discoveries in dark matter and modified gravity. Early in the year, astronomers announced results from the Vera C. Rubin Observatory, which began operations in 2024. The observatory performs a legacy survey of space and time, imaging the entire southern sky every few nights. One goal is mapping dark matter distribution by observing how galaxies cluster and how light bends around large structures. Recent results show galaxy rotation curve discrepancies that don't perfectly match standard dark matter models. Rotation curves describe how fast stars orbit the galactic center at different distances. Galaxies with only visible matter would have outer stars orbiting slower per Kepler's laws. Observations show they orbit faster than inner ones, implying more mass than seen. This invisible mass is called dark matter. New Rubin observatory data shows dark matter distribution in some galaxies is more clumpy or diffuse than models predict. This means our understanding of dark matter is incomplete, suggesting modified gravity theories as alternatives to general relativity to explain galactic dynamics without invoking invisible matter. The implications are profound. Dark matter is thought to make up about 85% of the universe's total matter. Yet it's never been directly seen. Its presence is inferred from gravitational effects, how galaxies rotate, how light bends around galaxy clusters' cosmic microwave background structure. But we don't know what it's made of. Decades of experiments searching for dark matter particles, weakly interacting massive particles or WIMPs, have yielded no results. Detectors deep underground, shielded from cosmic rays, wait for dark matter particles to collide with atomic nuclei. So far, no definitive results. The Rubin observatory data adds uncertainty. If dark matter distribution doesn't match models, we're missing something fundamental about how it works. Or perhaps the more radical possibility, dark matter doesn't exist at all. Gravity itself behaves differently on large scales than thought. Modified gravity theories like modified Newtonian dynamics, or MOND, propose Newton's laws break down at extremely low gravitational accelerations in galaxy outskirts. Instead of invoking invisible matter, the theory adjusts the equations of motion. It successfully explains galaxy rotation curves without dark matter, but struggles with other observations like gravitational lensing and cosmic microwave background. The debate between dark matter and modified gravity has raged for decades. Most physicists favor dark matter as it fits more observations and integrates well with particle physics and cosmology. Yet the lack of direct detection keeps modified gravity theories alive. How does this relate to 3I Atlas observations of non-gravitational acceleration in objects like 3I Atlas? Assume the gravity model is accurate. Object positions are calculated based on solar gravity, planetary gravity, relativistic effects. Any deviation from prediction is considered non-gravitational, meaning some cause other than gravity. But what if the gravity model is slightly wrong? What if a small correction to gravity, an undetected subtle effect? Then interpreting thrust from outgassing might be a misunderstanding of basic physics. The hypothesis is far-fetched but worth considering. History shows orbital anomalies leading to new physics. Mercury's orbit precessed slowly in its ellipse, unexplained by Newtonian gravity. Einstein's general relativity resolved it, proving space-time curvature near the Sun causes the effect. Could anomalies in small body orbits hint at something similar? Probably not. The scales differ. Dark matter and modified gravity operate on galactic scales with weak fields over vast distances. The inner solar system, where 3I Atlas moves, is dominated by the Sun's strong field. Modified gravity corrections would be tiny, much smaller than the observed acceleration. Gravitational acceleration at Earth-Sun distance is about 6 mm per second squared. At 3I Atlas perihelion, around 1.4 AU, it's stronger. Modified gravity theories predict deviations from Newtonian gravity on accelerations below about 10 to the minus 10 AM per second squared, weaker by 100 million times than 3I Atlas. So any modified gravity effect is utterly negligible here. Yet recent dark matter studies remind us our understanding of gravity and mass is incomplete. We don't know what dark matter is made of. We've never directly detected dark matter particles. Its existence is inferred from gravitational effects whose nature we don't understand. The mystery is deeper when considering the universe's scale. The universe's accelerating expansion is driven by something called dark energy. Like dark matter, we know nothing about it. It accounts for about 68% of the universe's energy density. Yet it's completely invisible, detected only through gravitational effects. So about 95% of the universe dark matter plus dark energy is stuff we don't understand. If mass distribution models are incomplete, could small accelerations be mismodeled? Solar radiation pressure, Interplanetary medium drag. Solar wind interaction stronger than thought. These are natural forces not requiring strange new physics but perhaps underestimated. Solar radiation pressure sunlight impacting space objects. The effect is tiny for large objects, significant for small particles or objects with large surface area to mass. Astronomers account for this in orbit calculations depending on size, shape, reflectivity. If parameters are uncertain, radiation pressure estimates could be off. The Yarkovsky effect is another subtle force. A rotating object absorbs sunlight, heats up. The hot side radiates energy as infrared, creating small thrust. Over time, it significantly changes asteroid orbits, drifting inward or outward over millions of years. Again, astronomers model it, requiring knowledge of thermal properties, rotation rate, surface composition. Interplanetary medium drag is even subtler. Space isn't a perfect vacuum. Sparse plasma and charged particles flow from the sun. Objects moving through the solar wind experience very small drag. For most objects, it's negligible, but for a large, fast object like Atlas relevant, the measured 0.02 mm per second squared acceleration is very small. It lies at the boundary of reliable measurement. Small systematic errors in astrometry, slightly mismodeled planetary perturbations or unaccounted forces could mimic non-gravitational acceleration. Astrometry measures precise object positions against a star background, challenging. Tracking a faint moving dot against fixed stars to arc-second precision. Atmospheric turbulence blurs images. Telescope optics imperfections cause aberrations. Timing uncertainties add noise. Even the best instruments have measurement errors. Orbit fitting to astrometric data solves complex equations balancing solar gravity, planetary gravity, sometimes large asteroids. If measurements have small systematic errors, slightly off timing, or the star catalog used for positions has errors, orbit adjustments leave residuals. Residuals can look like real non-gravitational acceleration but are just noise. Yet astronomers are meticulous. They account for known forces. They model solar radiation pressure, Yarkovsky effect from sunlight absorption creating small thrust. Relativistic effects, planetary gravity. Reported residual acceleration means factors don't explain observations. Jet propulsion laboratory data, large Atacama millimeter array. Sources, Avilobe sites are world-class. Measurements reliable. The 4 arc-second deviation mentioned is significant, far above noise. So non-gravitational acceleration is likely real, not data artifact. Yet how to explain the acceleration's cause remains open. Outgassing is the default explanation. As discussed, it requires high mass loss rates not clearly observed. Are there other natural mechanisms overlooked? Possibility of fragmentation. If 3I Atlas breaks apart, debris falls, heats up, debris pushed out carrying momentum. Reaction force accelerates the main body. This is similar to outgassing but mechanical fragmentation rather than sublimation. Comets sometimes split, especially under tidal stress or rapid rotation. If 3I Atlas is a rubble pile, a loose aggregate of rocks and ices barely held by gravity, it's unstable. Another possibility, electrostatic effects. Space objects accumulate charge from solar wind and cosmic rays. If charge distribution is asymmetric, interaction with interplanetary magnetic field creates small force. This is speculative. The effect is tiny, a natural mechanism not requiring outgassing thrust. The link between 3I Atlas and dark matter is more speculative, a springboard to consider the boundary between known and unknown physics. Could interstellar objects exploit some form of reaction thrust from the surrounding environment not yet known? If gravity and mass models are incomplete, does non-gravitational acceleration mean something else than thought? Imagine a fifth force beyond gravity, electromagnetism, strong and weak nuclear forces. Physicists have searched for a fifth force for decades, conducting precision experiments testing if gravity behaves exactly as general relativity predicts. So far, no confirmed deviations. Gravity might be special in scales or regimes not fully explored. Interstellar objects like 3I Atlas come from different environments interacting with force fields not encountered by solar system objects. formed in another star system under different conditions, including elements or structures reacting to the interplanetary medium in unexpected ways. These are provocative questions not to distract from more mundane explanations. Outgassing remains the leading hypothesis. The object is likely a comet with unusual properties not manifesting new laws of physics. Science doesn't need wild guesses. Observations decide. If 3I Atlas shows all the hallmarks of a comet, massive outgassing, cometary head-tail, spectral signs of volatiles, the acceleration is explained. If not, anomalies persist without clear natural mechanism, opening the door to stranger possibilities. The dark matter and modified gravity link is more philosophical than practical. It reminds us the cosmic picture is incomplete. We're still learning, discovering, adjusting models. 3I Atlas is just one data point in that ongoing process. Next, explore how artificial intelligence is changing orbit prediction, anomaly detection, and clarifying the true nature of 3I Atlas. Part 13. AI-driven astronomical orbit prediction tools. Artificial intelligence is transforming how we study the universe. Machine learning algorithms process vast data volumes, identify patterns, flag anomalies, and make predictions faster and more accurately than traditional methods. In 2025, several new AI tools were released with definite impact on astrometry and orbit prediction. For example, OrbNet, a neural network developed in collaboration between universities and space agencies. OrbNet ingests astrometric data, observes positions of objects over time, and compares to purely gravitational models. It outputs residuals, the difference between observed and predicted positions, flagging objects with significant deviations. OrbNet is trained on decades of asteroid and comet data. It learns what is normal and what is not. Encountering an object like 3I Atlas with measured non-gravitational acceleration, it not only flags it, it suggests potential causes based on previously seen models. Outgassing, fragmentation, collision, radiation pressure, even unidentified thrust. Why important small orbital deviations can be missed or mismodeled in classical methods. Humans fitting orbits to data might dismiss small residuals as noise. AI can analyze thousands of parameters simultaneously, detecting subtle patterns. For 3I Atlas, AI systems refine the orbit, detect small thrust vectors, helping rule out or confirm controlled hypotheses. If the object's acceleration changes over time, varies with solar distance, or shows inconsistent direction with outgassing processes, AI detects it. Another tool, Astro AI, released this year by the European Space Agency. It uses reinforcement learning to predict future positions of near-Earth objects and interstellar visitors. Trained on historical data and millions of simulated possible orbits, Astro AI estimates what corrections are needed to achieve specific outcomes, like aligning with the target. Researchers use the Astro AI to analyze 3I Atlas. Input the observed acceleration, current orbit, Earth's position. AI runs simulations to see what velocity changes, applied when and in what direction, lead to Earth intersection on the 19th of December. The answer is clear. The required delta 5 is many times larger than 86 knots per second. It needs several kilometers per second applied months earlier with precise vectoring. The social media claims don't hold up to rigorous modeling. This is AI's strength, exploring parameter space, testing thousands of scenarios in seconds. Astronomers typically hand calculate one or two scenarios. AI calculates them all, determining what is physically reasonable. Yet AI has limitations. It's only as good as its input data. If astrometric observations have systematic errors, or the object's motion is more complex than assumed models, AI can produce misleading results, flagging false anomalies or missing subtle effects not in training data. Also, AI identifies correlations, not always causation. Noting acceleration correlates with solar distance suggests outgassing, but can't specify the exact chemical process driving it. That requires spectroscopy, imaging, human interpretation. AI's role in 3I Atlas research is supportive, not decisive. It helps refine orbits, detect patterns, rule out unreasonable scenarios. But the final judgment, whether the object is natural or artificial, comet or probe, rests on observational evidence and scientific reasoning. Another AI aspect in astronomy worth mentioning: radio signal pattern recognition. The search for extraterrestrial intelligence generates massive data. Radio telescopes scan the sky recording signals across millions of frequency channels. Most detections are noise, human interference, or natural astrophysical sources. Finding real techno-signatures, artificial signals from another civilization, is like finding a needle in a galactic haystack. Artificial intelligence is invaluable. Algorithms trained to recognize noise patterns flag potential signals for human review. Filtering terrestrial interference, identifying frequency drifts consistent with orbiting transmitters, detecting modulation patterns suggesting information content. If 3i Atlas emitted a radio signal the 1.4 GHz ping, claimed in social posts, AI would detect it. No major observatory has reported such a signal despite continuously monitoring the sky. Strong evidence it doesn't exist. AI wouldn't miss something like that. If structured radio emission directed from the object, it would be flagged, analyzed, confirmed, or explained as interference. So AI-driven orbit prediction and analysis by late 2025 and early 2026 will provide updated precise orbits for 3i Atlas. Quantified residuals with high accuracy. Any continued acceleration mapped in 3 dimensions. Correlations with time, solar distance, rotation, other factors determined. Controlled hypotheses claiming Earth targeting definitively debunked. AI tool transparency contributes to public trust. Results replicable, verifiable by independent researchers. Unlike proprietary closed models, open source AI platforms allow anyone with the data to run their own analysis. This democratizes science, making misinformation harder to take root. Next, delve into radio astronomy advances, especially the 1.4 GHz band and its significance for potential techno-signature detection in objects like Atlas. Part 14, Radio Astronomy Advances in Deep Space and the 1.4 GHz band and beyond. Radio astronomy had a notable year. Early in 2025, the Breakthrough Listen project, a major initiative searching for techno-signatures, announced results from a survey covering millions of stars in the 1.2 to 1.8 GHz band. This range includes the 1.4 GHz hydrogen line, considered a prime interstellar communication channel. The survey found no confirmed techno-signatures, placing strict limits. If a civilization were broadcasting strong radio signals at 1.4 GHz within a few thousand light-years of Earth, it would have been detected. The silence is informative. It suggests intelligent civilizations are very rare. They don't broadcast in this band. Signals are too weak to detect, or they deliberately stay quiet. Advances in signal processing, larger arrays. AI-driven filters make radio astronomy more sensitive than ever. The Meerkat Array in South Africa, the Very Large Array in New Mexico, and the upcoming Square Kilometer Array will push sensitivity further. We're entering an era where detecting faint radio emission from nearby stars or passing objects is not just possible but routine. This leads to the social media claim of a 1.4 GHz ping signal from 3i Atlas. The claim the object emitted a structured signal near Mars, possibly a handshake communication to adjust its course. The choice of 1.4 GHz frequency is significant. It lies in the waterhole, a quiet region of the radio spectrum where galactic background noise as minimal signals propagate efficiently. If an advanced civilization wanted to send a detectable signal to another 1.4 GHz is a logical choice. It's universal. The hydrogen line is the same everywhere in the universe. Any civilization with radio astronomy would recognize it, but the issue: no peer-reviewed public detection of such a signal from 3i Atlas. Radio telescopes continuously monitor the sky. Breakthrough Listen, especially searches for transient bursts and unusual phenomena. If 3i Atlas emitted a 1.4 GHz ping, strong enough to be detected from Earth near Mars, someone would have noticed. Too weak a signal. Possibly, radio signals weaken with distance by the inverse square law. At 1 to 2. AU, a weak transmitter might fall below detection thresholds, then not detected near Mars, as the social post claimed. Short, intermittent burst missed. Possibly, radio observations aren't continuous. Telescopes have limited observing time, not always pointed at the right spot at the right moment. A short burst could slip through the cracks. but lack of any independent confirmation is suspicious. If the ping were real, multiple observatories should have detected it long ago. In reality, no evidence suggests the claim has basis. Consider technical feasibility. Assume 3i Atlas is an artificial probe. What would it take to transmit a 1.4 GHz signal detectable over interplanetary distances? Radio transmission needs power and an antenna. Power depends on the energy source and transmitter design. Antenna efficiency depends on size relative to wavelength. 1.4 GHz has a wavelength of about 21 centimeters. A reasonably efficient antenna a few meters in diameter, small enough to fit on a spacecraft. If the probe has a nuclear power source or long-lasting alternative providing a few watts to kilowatts of radio power feasible, that would be enough to be detected over millions of kilometers with sensitive receivers and directed antennas. Yet natural sources produce radio emission. Comets interacting with the solar wind create plasma instabilities emitting radio waves. Lightning and dust clouds can create broadband radio pulses. Rare phenomena, but they occur. So even detecting radio emission from 3i Atlas wouldn't mean it's artificial. We'd need to analyze the signal structure, look for modulation, repetition, frequency, drift, anything. Suggesting information content beyond random noise. What to watch for in the coming weeks. Upcoming coordinated radio astronomy observation campaigns targeting the 3i Atlas region. Multiple observatories covering different frequency bands and times. Data release schedules will bring results by late 2025 or early 2026. SETI organizations are paying attention. Breakthrough Listen added 3i Atlas to its target list if anything unusual in the radio spectrum is found. Radio astronomy's role is to investigate, confirm, or rule out technosignature hypotheses. No signal detection despite careful monitoring collapses the hypothesis. If a signal is detected and verified, the conversation changes dramatically. Radio astronomy is the tool to expose the truth. Many anomalies from fast radio bursts initially thought alien to mysterious microwave pulses. Explained by observatory cafeteria sources turn out natural or artificial. The field has a culture of skepticism and verification. Whether 3i Atlas is natural or artificial, radio astronomy is a pioneering exploration tool. For now, the object's silence means more than any alleged ping. Next, wrap up the investigation considering what we've learned and where things head by late 2025 and early 2026. Part 15 summary and what happens next in late 2025 and early 2026. Putting it all together, it started with dramatic claims 3i Atlas might align with Earth. The claims, based on real data, reported non-gravitational acceleration of 0.02 m/s per second. Squared simple calculation showing 50 days of such acceleration creates an 86 m/s per second velocity change. The math is accurate. The data is real, but the extrapolation is a leap, assuming the acceleration is aimed at Earth based on unverified assumptions. The acceleration would need to persist continuously in the right direction, syncing perfectly with Earth's orbital position at the right moment. No information confirms that. Check the orbit miss distance. Official sources have 3i Atlas flying past Earth at approximately 1.88 AU, about 270 million kilometers, on the 19th of December 2025. A very safe distance. Turning that into an intercept would require far greater velocity change applied over a longer period with precise timing. The numbers don't support the Earth alignment claim. Explore natural explanations for the acceleration. The default hypothesis, outguessing sublimation of ices creating thrust. Yet the required mass loss rate is very high, at least 1/16 of the object's mass per month. If Avi Loeb's calculations are correct, it would create a gigantic gas cloud. Telescopes haven't definitively observed. Still no conclusion. Consider strange hypotheses. Could 3i Atlas be an artificial probe from another civilization? The acceleration size orbit raised many questions, but no clear evidence, no radio signals, no signs of constant thrust, no verifiable artifacts. The hypothesis remains intriguing speculation unproven. The social media story amplified claims, turning an unusual scientific phenomenon into an alien intervention narrative. Stories spread faster than science, blurring the line between data and interpretation. A reminder of how information flows in the modern age, how uncertainty becomes spectacle, how pattern-seeking minds fill gaps with drama. Consider what happens if the worst-case scenario occurs. If the object somehow impacts Earth, the consequences would be catastrophically extinction level. But the chain of assumptions needed is very long and fragile. The object would need intentional capability and near-impossible timing. Broaden the scope, connecting 3i Atlas to wider trends in space science. Exoplanet atmosphere imaging, dark matter studies, AI orbit prediction, radio astronomy all contribute context. The issue isn't one object. It's how we study the universe, how we detect anomalies, how we interpret data, how we prepare for the unexpected. Key takeaways. First, 3i Atlas is a rare interstellar visitor of immense scientific value, whether natural or artificial. Second, the 86 ames per second velocity change calculation is accurate, but doesn't automatically imply Earth impact. Third, key unknowns remain. The acceleration vector, whether it persists, how it compares to Earth's orbit. Fourth, observations expected in late 2025 are critical. Mass loss data, astrometry, spectroscopy, radio monitoring, all will clarify the object. Fifth, though the worst-case scenario is tragic, it depends on many untested assumptions. Official agencies confirm no threat. Sixth, broader science fields converge on Atlas, making it a nexus for multiple research directions. Timeline rundown. Perihelion occurs around the 30th of October 2025. The body passes closest to the Sun and is now heading outward. November marks ramped-up observation campaigns. The object gradually escapes solar glare, becoming easier to observe. The 19th of December 2025 is the closest Earth approach date. The date social media pointed to. By then, many more weeks of data. Early 2026 begins the outbound phase. A distant Jupiter flyby might occur around March. After that, 3i Atlas fades, moving deep into the outer solar system, eventually returning to interstellar space. What to watch: official orbit updates from NASA, ESA, and other space agencies. Look for detailed missed distance calculations, any orbital changes. Pay attention to the spectral results. Detection of volatile substances, anomalous signs, color still unusual. Pay attention to imaging reports. High-resolution Hubble JWST images reveal surface features, jet stream different structure. Follow radio telescope announcements. Any detection of 1.4 GHz frequency signal, other frequencies, big news. Also consider contrast media narrative scientific claims. How mainstream media reporting the event emphasize caution, sensationalism. How scientists reacting to social media claims. Interaction, public perception. Scientific accuracy, part of the story. If nothing noteworthy appears early 2026, what does it mean? Meaning shifted, claim wrong. Almost certainly, if object behaves like comet shows, outgassing, predictable, weaken, moving away. Sun. If acceleration decreases, stops, no radio signal detected, natural explanation prevails. 3 Atlas joins ranks, interesting interstellar visitors, ultimately normal. But if anomalous phenomena persist, acceleration continues increasing away. Sun mass loss very small, despite thrust radio signal mysterious, detected for real. Then strange hypothesis, no longer speculation, starts demanding serious investigation. Whether 3 Atlas stable, interesting natural state becomes first confirmed human-made interstellar probe. Answer: not social media speculation to telescope data. Patient work, scientists measure, analyze, interpret. Final thought: universe owes no comfort, doesn't care, ready discover reveals. Most human history believed alone. Earth center, everything universe revolved around. Each major discovery humbling step forward. Learned Earth orbits Sun. Learned Sun, 1 billion planets. No galaxy, not limited count. Now no celestial bodies other star systems visit. What happens visitor to something not easily explained? 3 Atlas anyway, step forward journey. If comet understand more diversity interstellar visitors. If something else no galaxy more interesting crowded than thought. Either way, galaxy reminds look up curiosity. Ask questions, prepare possibilities not yet considered. Investigation not over. Just beginning. Coming months tell social media claims pipe dream something stranger happening. Early 2026 no. Until then observe sky, universe watching. Comets frequently experience this phenomenon. When ice sublimates transitions from solid to gas, it escapes surface creates thrust. Like rocket effect weak but measurable. Challenge with 3I map is ratio. If this object has mass large as some estimates tens billions tons, then losing 1016 that mass in 1 month would create spectacular gas dust cloud. Visible smoke cloud tail something we could detect. Visually, 3 Atlas images have shown some unusual features. Images show jet structure possibly directed towards sun. Instead away, not common. Object color also draws attention. Reports describe it greener than sun, possibly sign ionized carbon monoxide rather than ordinary dust. These clues, but not conclusive. Comets can be strange. Interstellar comets even stranger. Data not show anything low himself, not claim object on Earth intercept orbit. He not say deliberately moving toward us. Data show acceleration. They show deviation. They suggest something interesting happening. Leap Earth intercept purposeful drive from elsewhere comes social media. Post takes low data runs calculation. This main difference. This data intriguing but not inexplicable. Hyperbolic interstellar object some outgassing jet structure fits known physics. At unusual level certainly but not impossible. Question whether data supports bold claim. 3 Atlas actively changing course toward Earth, or someone took real data. Added many layers. Assumption reach. Shocking conclusion. So far what we have real confirmed interstellar object. Its orbit relatively close Earth but still very far. Non-gravitational acceleration could outgassing or could another cause. And calculation shows mathematically small continuous thrust over 50 days could lead significant velocity change. Whether enough claim object aligning Earth. That question addressed next, examining math assumptions turn data narrative. Part 3 Extrapolation. Earth intercept point. Math assumptions. Let's do calculation. Social media claims start simple equation classical physics. Acceleration time equals velocity change. If constant acceleration 0.0 is 2 meters second squared, maintain 50 days velocity change, how much 50 days? 320,000 seconds. Multiply that 0.02 mimics second squared. 2 x 10. 5 mim second squared get approximately 86.4 meters second. That delta V velocity change. Calculation correct. Nothing argue arithmetic itself. Now talk displacement. Apply constant acceleration over time, not only change velocity, also change position. Displacement constant acceleration. 2. Acceleration. Time squared. Plug numbers. 1 plug 2. 2. 10. 5 ms squared. 4.32. 10. 6 squared. Get approximately 1.87. 10 is 8 May, i.e. 187,000 km, nearly half Earth-Moon distance. So yes, these numbers not trivial. Small continuous thrust over 50 days can shift object orbit hundreds thousands km. Orbital mechanics context significant. Can change position timing object crosses specific plane. Can change miss distance. Theoretically can turn distant flyby closer one. But here assumptions start piling up. Calculation assumes acceleration continues undiminished 50 days. Is that true? We don't know. Acceleration measured specific point near perihelion. Whether this acceleration persists weeks, months, unclear. Outgassing typically varies distant sun. Object moves away. Perihelion solar heating decreases. Sublimation rate decreases. Thrust may weaken or stop. Calculation also assumes acceleration applied exact vector. Direction is important magnitude. If thrust lateral orbit Earth can change orbital plane, not significantly change misses distance. If thrust forward accelerates object changes arrival time. If retrograde slows down same. If radial pushes toward or away, Sun changes semi-major axis eccentricity. Without knowing acceleration direction integrating velocity change, orbit prediction speculative. Timing another key assumption. Object must apply thrust right. Moment right direction path creates intersection. Earth orbit, Earth actually there. Earth moves 30 kilometers second around Sun, travels vast distance many days. Hitting moving target requires precise timing navigation. 187,000 kilometers shift can move intersection point. But if Earth not there that moment, no intersection. Next energy mass issue. If object mass estimated tens billions tons, sustaining thrust requires enormous energy. If natural outgassing mass loss rate high, low calculated. If artificial implies propulsion system capable long-term thrust. Both scenarios unlikely unless see supporting evidence. Finally, perturbation issue. Space, not empty. Solar radiation pressure, planetary gravity, solar wind, even Yarkovsky effect can affect small object orbit. This simple calculation assumes these negligible or average out. Reality introduced noise uncertainty. Perfectly deterministic 50-day burn idealization. Lead analogy. Imagine driving highway. No can accelerate 60 km/h faster current speed, like knowing delta V. But merging correct lane reach specific exit requires more than speed. Need no exit where traffic speed when accelerate steering direction. Math velocity change one thing. Geometry timing. Orbital mechanics another. Social media extrapolation assumes acceleration acting beneficial direction Earth alignment. We know evidence that. Data show acceleration not its vector relative Earth orbit. Claim further says this acceleration purposeful targeted Earth. That interpretation layered data not derived data. Here what we know versus assumed. We know non-gravitational acceleration. We know small measurable. We know object orbit brings relatively near Earth December. We assume this acceleration lasts 50 days. We assume directed right way. We assume timing matches. We assume no other factors intervene. We interpret all that purposeful maneuver toward Earth. Each assumption link chain. Break one link, entire claim collapses. Issue not whether calculation correct. It is. Issue whether real world follows those assumptions. Next, examine actual orbit missed distance. See whether 86A intercept change can really turn 270 million kilometer flyby. Something more concerning. Part 4. Object orbit missed distance. Official figures clear. According NASA European Space Agency 3I Atlas flyby Earth approximately 1.8 to 8 astronomical units December 19, 2025. This distance equivalent about 270 million kilometer. Perspective 1. Astronomical unit average Earth-Sun distance about 150 million kilometers. So 1.8 astronomical units means object nearly twice far its closest position. This distance not close. Not any standard used planetary defense. Object considered potentially hazardous orbit within 0.05 astronomical units Earth, about 7.5 million kilometers. 3 Atlas flyby more than 30 times that threshold. NASA ESA both clearly stated this object poses no threat Earth. So how missed distance work? Orbital mechanics object approaches. Hyperbolic orbit path. Determined velocity direction gravitational influences. Missed distance basically closest approach point calculated based object orbit. Relative Earth position specific time. For Atlas 3I that calculation yields 1.8 astronomical units December 19th. Now address main question. Can 86 ms velocity change significantly alter that missed distance? Answer yes or no depending context. Yes, principle 86. ms delta V applied 50 days can shift object orbit hundreds thousands kilometer. Calculated earlier displacement around 187,000 kilometers. Number not small. Orbital mechanics small velocity changes. Large position changes over time especially applied early orbit. But no turning 270 million kilometer miss into Earth collision would require far more than 86 materials. unless vector timing extremely favorable. Object moving 60 km, 60,000 ms, 86 ms less, 0.15% total velocity. Change orbit enough shift miss distance 270 million km to 0, need much larger delta V, or near perfect alignment thrust direction timing. Thrust direction everything. Imagine object orbit straight line space. Push sideways perpendicular velocity vector change orbital plane. Can shift path 100,000 kilometers sideways not necessarily bring closer Earth. Push forward backward along velocity vector change arrival time. Object reach Earth solar plane earlier later. Again not guarantee closer approach unless Earth happens right spot. Push radial toward away. Sun change orbit shape eccentricity perihelion distance. Concept orbital mechanics called B-plane. Virtual plane perpendicular incoming orbit use calculate object intersection position relative target. Imagine dartboard. Bullseye Earth. Object orbit pierces plane. Some point distance bullseye. That point miss distance. Small velocity change can shift object intersection position plane moving edge dartboard center requires very specific thrust. Without knowing 3I Atlas non-gravitational acceleration direction relative Earth position cannot say actual miss distance change how much. Social media claim assumes thrust right direction. Big assumption. Also object mass issue. Estimates show 3 Atlas very large, possibly over 33 billion tons, diameter few kilometers. Maneuvering such size object very difficult natural outgassing mechanism. Basically trying steer mountain evaporating ice surface. If mechanism artificial implies engine propulsion system immense power. Either way, physics challenge. NASA ISIS scientists access full astrometric data orbit models concluded object not Earth intersecting orbit. Accounted uncertainties, perturbations, potential non-gravitational forces. Models show safe path. If numbers showed otherwise, even small collision probability alarm bells ring. Planetary defense networks exist precisely identified track potentially hazardous objects. 3 Atlas not their threat list. So reality check miss distance leads this. Geometry timing make Earth collision scenario this stage highly improbable. Object need much larger velocity change, very specific direction, very specific time turn. 270 million km flyby. Something dangerous. These numbers can look alarming, focus only. Delta 5. Calculation, big picture, orbital mechanics timing. Miss distance, all point distant passage. Does not mean object not interesting. Far from it. Non-gravitational acceleration. Unusual features fact. Interstellar visitor all make scientifically valuable, but Earth intercept scenario assertion matching us remains speculation. Next explore ongoing observation campaign telescopes pointed. 3I Atlas testable predictions soon reveal whether object comet probe something in between. Part 5 Observation campaign testable predictions. Coming months critical. Now early 2026 3I Atlas closely monitored. Telescopes worldwide space tracking it. Passage perihelion around October 30, 2025 closest sun. Now heading outward approaching Earth December 19th. This observation window not last forever. Object passes Earth moves deeper outer solar system fade view. Key instruments campaign include humanity most powerful tools. Hubble Space Telescope high-resolution imaging visible ultraviolet wavelengths. James Webb Space Telescope infrared capability detect thermal signs, analyze composition any gas dust surrounding object. Ground observatories. Very Large Telescope VLT. Chile. Keck Observatory Hawaii contributing. Radio telescopes listening unusual emissions. Closer Mars orbiters may glimpse 3I Atlas flyby relatively near red planet. Also interesting coincidence. November 4, 2025, European Space Agency Jupiter. Icy moons explored juice flyby, within 64 million km 3I Atlas. Distance not close dedicated flyby juice instruments may collect data distance. Every bit helps. Avibe other researchers made testable predictions. These predictions depend whether non-gravitational acceleration natural outgassing other cause. If cause outgassing mass loss significant, low calculation shows least 1 acorn 16 object mass evaporate about 1 month. Create enormous gas dust cloud visible coma, possibly tail trailing object solar wind pushes particles away. So first prediction simple. If acceleration natural telescopes detect large gas, dust envelope. Spectroscopy show presence volatiles, water, carbon monoxide, carbon dioxide, methane. Object behave like comet, exhibit all typical sublimation activity signs, but no large cloud appears. Mass loss minimal, none natural outgassing hypothesis weakens. Significant result. Means acceleration comes something else not require ejecting large material. That explanation's non-natural technological start seem plausible. Measurements track include astrometric residuals. Difference actual object position versus position purely gravitational model predicts. These residuals reveal magnitude, direction, any non-gravitational force. Coming weeks more. Observations, astronomers refine orbit, quantify acceleration, higher precision. Spectroscopy, another key tool. Breaking object light component wavelengths. Scientists identify molecules, atoms present. 3 Atlas noted unusual color described greener sun. Could indicate ionized carbon monoxide signs. Some comet types could mean something else. Detailed spectral analysis tell more composition whether matches known cometary chemistry. Imaging also crucial. Morphology, any coma, comet, tailjet. Structures, presence, asymmetry all provide clues. Some reports mention reverse tailjet streams directed towards sun instead away. Quite unusual, not unprecedented. Comets sometimes forward features geometry rotation. High-resolution imaging clarify what see fits natural processes. Also radio astronomy. Social media posts claim object sent 1.4 GHz. Ping alleged communication navigation signal. Completely unverified anyway, radio telescopes listening. Any unusual emission 1.4 GHz. Any frequency detected analyzed. Radio signals comets rare possible usually plasma interactions. A structured strong signal would be an entirely different matter. This observation campaign faces many challenges. Timing and geometry are critical around perihelion. The object was near the sun in the sky, making observations difficult without being blinded by sunlight. Now as it moves away from the sun and toward Earth, visibility improves. But by late December, after closest approach, it will start fading as it moves beyond both sun and Earth. The window is very short. Weather telescope availability, funding, and coordination all play a role. Not every telescope can observe every night. Data needs to be collected, analyzed, peer-reviewed, and published. Science moves slower than social media. Claims can spread in hours, but observations take weeks or months to confirm or refute. Still, this is an exciting time. We are watching a visitor from another star system in real time. Telescopes that observe distant exoplanets to probe exoplanet atmospheric chemistry are now pointed at something passing through our neighborhood. This is a rare convergence of opportunity and technology. By early 2026, we will have answers. If 3 Atlas comet behaves like a comet, showing massive outgassing, a cometary head, a cometary tail, and spectral signs of volatiles, then the natural explanation holds. Non-gravitational acceleration, just a comet doing comet things perhaps more intensely than usual due to its interstellar origin and composition. But if observations show very little mass loss, no significant cloud yet acceleration persists, or shows direction inconsistent with jet outflow, then we have a problem. Not a catastrophe, but a scientific puzzle that doesn't fit our models. That's when the story shifts. That's when strange hypotheses, the ones we'll explore next, stop being mere speculation and start demanding serious consideration. The next part of this investigation will dive into the debate between natural and non-natural, the role of social media in amplifying claims, and its implications if 3 Atlas turns out to be something other than a comet. Part 6. Non-gravitational acceleration natural explanations. Comets are dirty snowballs, or at least that's the simplified version we're taught in introductory astronomy. A comet nucleus is a mixture of ice rock and organic compounds. As it nears the sun, solar radiation heats the surface, causing ice to sublimate, transitioning directly from solid to gas without a liquid phase. The escaping gas carries dust particles, forming a cloud called a coma, and often a tail streaming away from the sun. This outgassing doesn't just create a spectacular sight, it also generates thrust. Gas molecules carry momentum. As they leave the comet nucleus, they push the comet itself in the opposite direction like a punctured balloon, zipping around a room. The effect is small, but measurable. It's called non-gravitational force, and astronomers have detected and modeled it for decades. So when AVI reported non-gravitational acceleration of 0.02 m/second squared for 3I Atlas, the first assumption was that it was releasing gas. That's the default hypothesis, the most natural explanation. But details matter. Lowe applied a momentum conservation equation to estimate the mass needed to produce that acceleration. The formula is simple. Force on the comet equals mass loss rate times exhaust velocity of the gas jet. Force equals mass times acceleration, so you can rearrange to find the mass loss rate. If exhaust velocity is a few hundred meters per second typical for cometary jets and acceleration equals 0. With 0.002 mm/second squared, you can calculate the comet's mass loss rate. The result is staggering. If 3I Atlas has a mass of about 30 billion tons, the calculation shows it would need to lose about 5 billion tons per month to sustain that acceleration. That number equals about 1/16 of its total mass in 30 days. In a few months, the comet would evaporate a significant fraction of its own mass. That's a massive mass loss. It would be obvious. Astronomers would see a gigantic gas and dust cloud enveloping the comet nucleus. The comet tail would be prominent. Spectroscopy would reveal abundant volatiles. Yet observations so far show something more subtle. There are reports of a jet structure possibly directed toward the sun, and this object's color is quite unusual, greener than expected. However, a gigantic gas cloud corresponding to that level of mass loss has not been clearly observed. That doesn't mean the natural explanation is dead. Comets are diverse. Outgassing can be episodic due to rotation, exposure of fresh ice layers, or surface layer collapse. Perhaps the high mass loss rate was temporary, a burst near perihelion that subsided afterward. Possibly the gas escapes in focused streams rather than uniformly, making the gas cloud harder to see from Earth. Possibly the gas composition is transparent or carries little dust, reducing visibility. The greener-than-sun color is intriguing. It could indicate ionized carbon monoxide, a molecule that can dominate the spectrum of some comets. Carbon monoxide ice is more volatile than water ice, sublimating at lower temperatures and greater solar distances. An interstellar comet could have different composition from solar system comets richer in carbon monoxide or other exotic ices, because it formed in a different stellar environment. Some images show what might be a reverse tail, a feature directed toward the sun instead of away. This is rare but not impossible. It can occur due to observation geometry when we view the comet from an angle that makes dust in the orbital plane appear forward-facing. Or, it could be a genuine forward-directed jet driven by rotation or localized heating. The natural explanation requires all these factors to align: large mass loss, unusual composition, episodic outgassing, and geometric effects. It's a complex picture. But comets are complex objects. They don't always behave the same. An interstellar comet formed in a different star system with different conditions could easily deviate from the models we see in solar system comets. There's also the issue of the object's size and mass. Estimates suggest a diameter of at least a few kilometers, possibly 5 kilometers or more, and mass exceeding 30 billion tons. That's a large comet. Accelerating such a large object through outgassing requires enormous energy and material, like trying to push a cargo ship by throwing cargo overboard. You can do it, but you need to throw a lot of cargo very fast. An analogy will help here. Imagine a giant container ship losing half its cargo in a month to gain a little speed. That's entirely possible but dramatic. You'd see containers floating everywhere. Debris fields evidence of the loss. Similarly, if 3 Atlas loses 116 mass in a month, we would see evidence. Gas dust, a glowing envelope. What would satisfy the natural explanation detection of a large coma matching the predicted mass loss rate? Spectroscopy confirming presence of water, carbon monoxide, carbon dioxide, or other volatiles in expected quantities. Imaging showing classic cometary tail structure, possibly multiple jets. And most importantly, acceleration must correlate with distance from comet to sun. As comet moves away from perihelion, solar heating decreases, outgassing weakens, and acceleration decreases. If not if, acceleration persists or even increases as comet moves away from sun. That's a red flag. Currently, the natural outgassing hypothesis is reasonable but contested. The required mass loss rate is high. Observational evidence is ambiguous. The object's size and mass make the story harder to swallow. But comets have surprised us before. Oumuamua surprised us with acceleration and elongated shape. Borisov surprised us by looking completely ordinary. 3 Atlas may be the next surprise. A comet with extreme characteristics pushing the boundaries of what we consider normal. Or it could be something entirely different. That's what we'll explore next. The strange technological hypotheses lie on the boundary between speculation and science. Part 7. Non-gravitational acceleration. Strange technological hypotheses. What if the acceleration is not natural? What if 3I Atlas is not just a comet doing comet things? What if it is something designed, something sent, something engineered? Avi and colleagues published a paper titled, "Could the interstellar object 3I Atlas be extraterrestrial technology?" This is not a joke. This is a serious scientific inquiry framed in the context of what we can and cannot rule out. The paper considers the possibility that this object is a technological artifact, perhaps a probe from another civilization. Why would anyone propose this? Several factors converge. First is the non-gravitational acceleration. If not due to outgassing, or if the outgassing explanation strains credulity due to the required mass loss rate, then we need alternative mechanisms. Second, the size and mass estimates. A large, massive object undergoing measurable acceleration implies significant energy and momentum transfer. Third, the orbit. Lowe noted that the object's path through the inner solar system, its timing and alignment with Earth's orbital plane, are statistically unusual. Not impossible, but unlikely if it's a random interstellar visitor. Energetics are worth exploring. An object with tens of billions of tons of mass sustaining 0.02 seconds squared acceleration for weeks. The required thrust is enormous. Force equals mass times acceleration. Plug in 1013 key and 2x10. 5 seconds squared, you get a force of about 200,000 newtons. That's the thrust of a small rocket engine continuously accelerating. But a solar sail would not be effective unless very large and highly reflective. Calculations show a sail large enough to accelerate this mass would need kilometer-scale diameter and precise orientation. Or perhaps something more exotic, an ion drive, a fusion engine, or a technology we haven't invented. The 4 GHz pings mentioned in the social media posts add another layer of speculation to this hypothesis. 1.4 GHz is significant in the search for extraterrestrial intelligence because it corresponds to the hydrogen line, a natural frequency emitted by neutral hydrogen atoms. It's sometimes called the water hole. In radio astronomy, a quiet band in the electromagnetic spectrum, where signals can travel through space with minimal noise. If an advanced civilization wanted to send a signal, 1.4 GHz would be a logical choice. But the issue here is, no publicly verified detection of such signals from 3 Atlas satellites. Radio telescopes continuously monitor the sky, and if a strong structured signal were emanating from the object, someone would notice. This claim remains unproven, mere speculation. Still, let's entertain the hypothesis. Suppose 3 Atlas is an artificial probe. What is its purpose? Reconnaissance, observation. Perhaps it has been drifting through space for millions of years. A relic from a long-dead civilization still executing its programmed mission to survey star systems. Or perhaps it is active, deliberately adjusting course to study interesting targets. Could it self-maneuver to intercept Earth? The short answer is yes, if it has the capability. A probe with a functional propulsion system could in principle change its orbit, but the delta V required to turn a 270 million kilometer missed distance into an actual intercept is far greater than 86 ms. You would need velocity changes on the order of km applied with precise timing and direction. That's a massive sustained thrust. Lowe has also discussed the dark forest hypothesis in relation to 3I Atlas, the dark forest idea popularized by science fiction author Lou Sixon. Posits that the universe is full of civilizations, but they remain silent to avoid detection by potential enemies. Revealing your presence could lead to destruction, so everyone stays quiet, hiding in the cosmic dark forest. Lowe speculates that if 3 Atlas is a probe, its behavior might reflect a cautious approach, observing from afar, rather than direct contact. This is highly speculative. Many layers of assumption are stacked. Assumption 1, acceleration is not natural. Assumption 2, it is artificial. Assumption 3, it is controlled by an intelligence. Assumption 4, the intelligence is cautious or purposeful in its Earth approach. Each assumption reduces the overall scenario probability. What would count as clear evidence of technological origin? A few things come to mind. Unexpected radio emission, especially structured signals containing information. Signs of non-evaporative thrust, meaning sustained acceleration without corresponding mass loss or gas release. Extremely low mass loss with high acceleration, violating rocket physics laws unless an external energy source. High surface reflectivity, suggesting engineered material for natural rock and ice. Attitude or orientation changes not explainable by tumbling rotation. If observations detect any of these, the conversation changes immediately. Suddenly, the strange hypothesis is no longer fringe speculation. It's a viable explanation demanding investigation. But if none of these signs appear, if the object continues to behave like a strange but natural comet, then the technological hypothesis will fade into obscurity. The stakes are enormous. If the probe scenario is correct, it confirms we are not alone. It means another civilization achieved the technology to send objects across interstellar space. This would raise questions about intent, longevity, and their fate. Are they still out there? Did they send 1 or 1,000 probes? Is 3 Atlas ancient or recent, but high stakes don't mean the hypothesis is true. Extraordinary claims require extraordinary evidence, and right now the evidence is ambiguous. Non-gravitational acceleration is real, but not definitively non-natural. The orbit is quite unusual, but not impossible for a random interstellar object. The radio signals are unverified. The lack of a large cometary cloud is suggestive but not conclusive. Science proceeds by testing hypotheses, making predictions, and comparing them to observations. The technological hypothesis also makes predictions. No large gas cloud because no outgassing. Acceleration persists even as object moves away from sun because thrust not solar-driven. Possible radio emission or other non-thermal signs. In the coming months, observations will test these predictions. If this object is natural, we still learn something valuable. We push the boundaries of cometary science, explore the chemistry and dynamics of interstellar visitors, and test our models in an extreme case. If the object turns out to be artificial, then it's the greatest discovery in human history. Either way, the observations in late 2025 and early 2026 will be riveting. Next, we'll examine how this story spread. How social media takes scientific data and turns it into a narrative of alien intervention and conspiracy. Part 8. The social media story and how conspiracy narratives are built. The posts appeared on X in mid-October 2025. An independent researcher unaffiliated with any major institution made a series of claims. The core was simple. 3I Atlas is accelerating. If it continues accelerating at 0.02 mm second squared for 50 days, it will achieve 86 ms/second velocity. That velocity change, if applied in the right direction at the right time, could align the object with Earth on December 19, 2025. Then the claims escalated. The researcher asserted this acceleration is not random. It is intentional. The object is moving, adjusting course, heading toward Earth. There were mentions of 1.4 GHz pings detected near Mars, alleged communications, handshakes between the object and something else. The story shifted from interesting scientific phenomenon to alien probe targeting us. Let's break it down piece by piece. The part about acceleration is real. Avi reported it. It's based on astrometric observations from reliable sources. The arithmetic calculation 0.8 out mm second squared x 50 days equals 86 meter second. That's also correct. Basic physics. No errors there. But then come the assumptions. Assumption that acceleration lasts exactly 50 days. Assumption that it is directed toward Earth. Assumption that the timing perfectly matches Earth's orbital position. None of these assumptions are verified. They're inferences, guesses based on limited data. The interpretation, the assertion that the object is aligning with Earth, that's where data ends and narrative begins. Alignment implies intent. It implies the object is purposefully self-maneuvering toward our planet. There is no evidence for that. For comparison, the largest nuclear weapon ever tested, the Soviet Union's Tsar bomber, had a yield of 50 megatons. This impact would be over 60,000 times more powerful. The consequences would be catastrophically devastating. An object of this size and speed would punch through the atmosphere in seconds. It would have no time to slow down or burn up significantly. It would slam into the surface at near maximum speed, releasing all its kinetic energy in an instant. The explosion would dwarf anything in human history, natural or artificial. Firestorms would rage across continents. Shock waves would level everything within hundreds of kilometers of the impact site. Earthquakes would ripple through Earth's crust. If it hit, the ocean tsunamis thousands of meters high would race across ocean basins at jet speeds. Coastal cities would be obliterated, but the immediate destruction would only be the beginning. The energy would vaporize the impactor, and vast amounts of rock, soil, or water ejected into the atmosphere. Dust and aerosols would spread globally within days, blocking sunlight. Temperatures would plummet. Photosynthesis would halt. Crops would fail. Famine would kill more than the initial impact. This is an extinction-level event, not necessarily the extinction of all life. Earth has survived worse, but the extinction of most large animal species, including humans. We're talking about a scenario equivalent to the impact that killed the dinosaurs 66 million years ago. Now consider a less extreme case. Suppose 3 Atlas does not hit Earth but passes much closer than the predicted 1.8 astronomical units. Suppose it flies by at tens of thousands of kilometers near geostationary satellite distance. What would happen? A close flyby would still be impressive. The object's gravity would perturb Earth's orbit slightly, though probably not noticeably. Earth is far more massive, so the effect would be tiny but electromagnetic, and plasma interactions could be fascinating. If the object has a magnetic field or carries charged particles, there could be auroras, radio interference, even temporary satellite disruptions. There's also the issue of debris. Uncertainty becomes spectacle, how pattern-seeking minds fill gaps with drama. We examined what would happen if the worst-case scenario occurred. If the object somehow impacted Earth, the consequences would be catastrophically devastating, an extinction event. But the chain of assumptions required is long and fragile. This object would need capabilities, intent, and timing that are nearly impossible. We also broaden the scope, connecting 3 Atlas to wider trends in cosmic science. Exoplanet atmospheric imaging, dark matter research, AI orbit prediction, and radio astronomy all contribute to this context. The issue is not just one object. The issue is how we study the universe, how we detect anomalies, how we interpret data, and how we prepare for the unexpected. So what are the key takeaways? First, 3 Atlas is a rare visitor from interstellar space, scientifically valuable, whether natural or artificial. Second, the calculation behind the 86 ms velocity change is accurate, but it does not automatically imply Earth impact. Third, critical unknowns remain. Acceleration vector, whether it sustains relative to Earth orbit. Fourth, observations expected in late 2025 are crucial. Mass loss, astrometric data, spectroscopy, radio monitoring, all will clarify what this object is. Fifth, while the worst-case scenario could be tragic, it still depends on many unverified assumptions, and official agencies affirm no threat. Sixth, broader scientific fields converge at Atlas, making it a hub for multiple research directions. Let's discuss the timeline. Perihelion occurred around October 30, 2025. The body has passed its closest point to the Sun and is now heading outward. November marks increased observation campaigns. The object is gradually escaping the sun's glare, becoming easier to observe. December 19, 2025 is the closest Earth approach. This is the key date, the one social media highlighted. By then, we will have many more weeks of data. Early 2026, the outbound phase will begin with a distant Jupiter flyby, possibly around March. Then 30 million. Atlas fades, moving deeper into the solar system's fringe and eventually back to interstellar space. What should you watch for official orbit updates from NASA, ESA, and other space agencies? Look for detailed calculations of missed distance and any orbit changes. Pay attention to spectral results. Detection of volatile substances, anomalous signs. Colors still unusual. Pay attention to imaging reports. High-resolution Hubble or JWST images may reveal surface features, jet streams, or other structures. Follow radio telescope announcements. Any detection of signals at 1.4 GHz or any other frequency would be big news. Also, consider the contrast between media narratives and scientific claims. How are mainstream media reporting the event? Do they emphasize caution or sensationalism? How are scientists reacting to social media claims? The interaction between public perception and scientific accuracy is part of the story. If nothing noteworthy appears by early 2026, what then does it mean the shift claim was wrong? Almost certainly, if this object behaves like a comet showing predictable outgassing that weakens as it moves away from the sun, if acceleration decreases or stops if no radio signals are detected, then the natural explanation prevails. 3 Atlas joins the ranks of interesting but ultimately ordinary interstellar visitors. But if anomalous phenomena persist, if acceleration continues increasing far from the sun, if mass loss is very small, despite thrust, if radio signals are detected, then we have a real mystery. That's when strange hypotheses are no longer speculation but start demanding serious investigation. Will 3 Atlas remain stable in an interesting but natural state, or will it become the first confirmed human-made interstellar probe? The answer doesn't come from social media speculation but from telescopes, from data, from the patient work of scientists who measure, analyze, and interpret. Final thought: the universe owes us no comfort. It doesn't care whether we are ready for its revelations. Over centuries, we have gradually realized we are not special, not central, not alone in any cosmic sense. Each major discovery is a step toward humility. 3 Atlas, whatever it is another step on that journey. If it's a comet, we understand more about the diversity of interstellar visitors. If it's something else, then we know this galaxy is more interesting and perhaps more crowded than we thought. Either way, this galaxy reminds us to look up. Stay curious. Ask questions and prepare for possibilities we haven't yet considered. The investigation is not over. It has only just begun. The coming months will tell us whether social media claims are a pipe dream or something stranger is unfolding. By early 2026, we will know. Until then, observe the sky. The universe is watching.